Participants, as we move past the opening formalities, we are now ready to dive deep into the technical substance of our theme, that is, digital construction and green design pathways to net zero. The session topic for today is implementing sustainable construction practices through improved contract management. This is where policy meets practice. It's not enough to design green buildings. We must ensure our project contracts mandate, measures, and enforces sustainable outcomes. We're incredibly fortunate to have a distinguished expert who brings vast academic research and industry experience to this topic. It's my privilege to introduce a resource person for this session, Dr. Murali Jagannathan. Dr. Jagannathan is currently an assistant professor at the Building Technology and Construction Management Division, Department of Civil Engineering, IIT Madras. He specializes in construction contracts and claims management and construction dispute resolution. His background is uniquely comprehensive, spanning the full spectrum of the construction field. Before joining IIT Madras, Dr. Murali was an assistant professor of construction management at NICMAR Pune, where he was involved in regular student teaching and management development programs. He also served as a faculty member at the L&T Institute of Project Management, focusing on training and development for professionals at India's construction firm L&T Limited. Dr. Murali brings rich industry experience, having worked with the business development team at L&T Construction and managing contracts in both brownfield and greenfield projects, which included handling extension of time (EOT) claims. His research, covering areas like contractual disputes and dispute resolution, has been published in renowned national and international journals. His deep expertise makes him the perfect guide for understanding how to embed sustainability into the legal and managerial DNA of a project. So, participants, please prepare your questions on contract clauses and sustainable requirements. We also use the chat box during the session for the interaction. And please remember to keep your microphones muted, use the chat box for the interaction, and pay close attendance for the attendance link that will be shared during the session. Without further ado, I welcome and hand over the session to Dr. Murali Jagannathan, sir. We eagerly await for your address.
Yeah, thank you, Akansha. I hope I'm audible to you all.
Yes, sir.
Yeah, thanks. So, thank you very much for that kind introduction. Let me just share my screen and start off the presentation. Just give me a second. Akansha, can you confirm if the screen is visible?
Yes, sir, it's visible.
Okay, great. Okay. So, before I start, I understand that this is a faculty development program and we are all from different backgrounds. So I have kept the presentation with as simple concepts as possible so that we all understand the common basic principles that I'm trying to talk today. And then, of course, last 15-20 minutes, I will leave it to the discussion so that we can build on certain concepts. If you feel some elaboration is required on certain concepts that we are discussing today. But right now, I will take you through the concept in a kind of a flow that will help you to connect the various concepts that we are going to discuss in the next 1.5 hours. Because the topic for the session is implementing sustainable construction practices through improved contract management. So in the topic itself, there are two things. One is sustainable construction practices, which is a field of its own. And we have something on contract management, which is again a field of its own. On top of this, I'll be introducing some other concepts during the discussion today so that we integrate all these concepts. And I finally end with kind of a framework that will help you to connect all these dots and will probably kindle further thoughts and maybe take you in more deeper directions. Since we are all faculty colleagues, I will also be touching upon a few concepts that you may probably find it useful for you to discuss such similar concepts in the class. Right, so I'll blend a little bit of practice as well as practice from the industry point of view, and also certain practices which I follow in my teaching, so that we can mutually learn from each other. And that's the objective that, again, I would like to put it up before we start. Okay, so let me make it full screen and start off. In case anybody feels you want to ask any questions, please feel free to unmute and ask questions if that is allowed. Otherwise, you can put it in the chat box. I will look at it maybe in the last 15-20 minutes, and we can take up some questions which are depending on how much time it's available. We'll take up certain questions. It's very important. And if you're allowed to, please unmute, interrupt me in between. I'm absolutely okay with questions in between as well. So with this, let me move on to the presentation. I hope my sound is audible, because I am getting a message that internet is unstable. I hope everything is clear, right? You're able to see me and see the presentation as well. Can anyone quickly confirm?
Yes, sir.
Okay, right, great. Just a minute. I'll just try to change my network. Just give me a second. Yeah. Okay. So we will get on to the discussions. Let me make it full screen. Okay. So the topic for the day is implementing sustainable construction practices through improved contract management. So what we are going to discuss in next 1.5 hours is something that we find it very commonly in practice, and we are trying to make sure that what we practice is something that is taking us towards implementing sustainable construction practices in projects. So just to give you an overview, in my opinion, sustainability can be achieved in projects through broadly two ways. Construction projects. When I say projects, I am talking about construction projects, and can be broadly achieved in two ways. One is I can explore alternative sustainable construction materials. Like, for example, I use highly carbon intensive or carbon footprint intensive materials for my projects, like cement, steel. And these are some of the materials that are, that if you look at the numbers, are some of the quite highly sustainability impacting kind of materials because of its production, logistics, transportation, and other things. So there's always a constant effort to explore what could be the alternative to the current materials, especially cement and concrete, steel, which can be explored to make our projects more sustainable. That's one direction in which we look at when it comes to making our projects more sustainable, wherein we are aiming at reduced carbon footprint to a better material choice. So that's one thing. The second is we are trying to improve our project performance through alternative construction processes. They say if you take any construction projects, there are two things, major things involved. One is the materials that you're going to use and the resources that you're going to employ in that particular project to deliver the final outcome. The second thing is the methodology or the methods that you're going to use to deliver this outcome. Let's say, for example, I use certain equipment to deliver the outcome. I use some drawings to deliver the outcome. So I use certain processes that are focused on achieving the final objectives as I've agreed in the contract with my employer. Now, the problem is these processes that I follow in projects are mostly prone to delays. Like, for example, you take any construction project that you see, especially like many public infrastructure projects that you see, we see that they are delayed. Right? So there's a metro construction that is going on. And near, very close to my house, there is a metro project construction that's going on in Chennai. It's been going on since 3 years. I'm here, and it's not such a massive project that it would take really 3 years to complete. But for some reason or the other, the project is getting on delayed. And there is one stormwater drain project that's going on very close to my house, because of which the road is, it's a quite a broad road, but in spite of that, almost 3/4 of the road is closed because of the stormwater drain project, which is running since 1 year. And again, it's not a very mega project. It's a kind of a small project, and it should not take 1 year, definitely 2-3 months, but not 1 year. But it's still going on. So likewise, you might have seen that in most of the public sector construction projects, they experience delays. And when the project gets delayed, of course, there is an impact on the cost and time, and that's one aspect of it. But when the project gets delayed, it also has a simultaneous impact on the sustainable development goals that we have as a country, right? Because assume that when a project gets delayed, the quality of life decreases, right? So, let's say I was telling you about the project close to my home. So, because of this extended construction period, some or the other breaking or excavation work is going on, because of which there's a huge amount of dust that is getting collected in the houses. So that's actually affecting the quality of life. That's one way. This, I thought it will happen for say 2 months or 3 months, but this is going on since past 1 year. Automatically, this is not sustainable in the long run if you keep on extending the project and keep on affecting the surroundings. Then because of this particular roadblock that has happened, there is a traffic diversion that is happening. So a road in which is capable of taking very comfortably taking peak hour traffic in the evenings of Chennai traffic is, it was actually a 6-lane road. It's now effectively reduced to a single lane road. Now imagine the extent of traffic jams that is causing. Imagine the extent of diversions that it is causing. Imagine the extent of chaos and confusion that is causing on the street. And we thought that it will be for 2 years, but it's still going on since 1 year. And we don't know how many years or how many months it will go on still. So these kind of projects, when they get delayed, it automatically has an impact on the way of life. And when we say way of life, it automatically impacts the sustainable development goals that we have as a nation or we have committed to as a country. Automatically, when projects get delayed, the whole supply chain gets affected, and the whole supply chain has its own impact on the environment in terms of its carbon footprint and everything. So everything gets affected. So what I'm trying to say is that one is the material component of the project, which has a direct influence on the carbon footprint. And other, you have the process component and the way you execute the project, the way you deliver the project, the kind of steps, methods or methodology or the steps that you follow to achieve the objectives, that is going to impact the timely completion of the project. And timely completion of the project will have an influence on the sustainable practices that we are going to follow. So the first thing that is about materials has a direct impact on sustainable construction practices. The processes have slightly indirect impact on sustainable construction practices. So when I say sustainability of construction projects, I refer to both these. That is, choosing alternative materials that can make things more sustainable, and also choosing alternative processes that can help me to achieve my project within the deadlines that I have committed. In other words, I'm able to achieve the progress that I planned, which means that I'm able to keep up my work productivity. Right? So how much work I do in a day will determine how much time I need to do the entire scope of work. If I don't do the work that I have to do in a day, which is called productivity, obviously my project is going to get delayed, and the delayed project has its own impact on the environment, on sustainability, on the way of life and things like that, which we have just discussed. So in today's presentation, I'm going to focus on these two aspects when it comes to construction practices and construction projects. But when I say, the moment I say alternative construction materials or alternative construction processes, I am talking about something that is different from what we do regularly. And the and the moment we try to do something different, it is always met with the resistance. Right? Because in general, as human beings, we are resistant to change. We don't want to change. We are happy with what we are doing. Yes, we may not be following certain practices which are not sustainable, and we may not be following certain practices which are actually helping us to complete the project on time. Agreed. But when somebody wants us to change, we automatically feel the difficulty to change. And that is a natural human tendency. Right? It's not so easy to change things, and it is not so easy to change certain practices that you have been adopting since so many years. The way I pour concrete is the way I pour concrete. And somebody asks me to change the way I pour concrete, I will resist because I am expert in pouring concrete the way I pour concrete. So why should I change? I'm using normal Portland cement, ordinary Portland cement, OPC, since so many decades. Now you suddenly come and ask me to change to some sustainable variety of cement. Why should I change? I'm happy with what I'm doing. So why should I change? So that resistance to change is something that's actually inherently available in most of the human beings that we have. Now, to break this resistance, this is where construction contracts play a key role. Now, I bring in the concept of construction contracts. Now, many of you might be wondering, all the while I was talking about sustainable construction practices, alternative materials, completing the project on time, productivity, and where this construction contract has come suddenly. Now, construction contracts are, I'm making a statement which I will prove it in a while. Construction contracts are some of the powerful instruments that can actually bring in the right behaviors which can lead you to adopt the change. Right? So I'll repeat, construction contracts are some of the powerful instruments that can actually promote the right behavior that can lead you to embrace the change that I'm talking about here. Right? I told about alternative construction materials. Nobody will even think of it when we are comfortable with what we are doing. But now, if I use the construction contract the way I'm going to explain in a short while, then this construction contract can become a very key instrument in enabling this change to more sustainable practices. See, ultimately, it is the question of implementing practices because we have a lot of ideas, but we have to implement it because even today the projects are getting delayed, right? So, which means that there's a huge scope for implementation. That's not happening, and that's to make it happen. Contracts play a very big role, is what something that I'm trying to say. Question: why? Why do you think contract is such a powerful instrument that can bring in positive change that can drive us towards sustainability? What is the magic that is there in the contract that can actually help us to do this? To understand this, I'm sure many of you will be knowing this, but just to have common understanding, I would like to give you a brief overview of what is a contract, construction contract, and what makes construction contract so powerful in implementing the right practices. So if you are knowing this already, so please bear with me for some time. I'll take about 5 minutes to explain the basic concepts of construction contract because some of you here may be aware of the word term construction contract, but you may not be aware of the proper definition in context of construction contracts trying to become a change agents to enable us to implement sustainable construction practices. Okay, so what is a contract? So many of you here might be knowing the meaning of contract, but even then, if I go with the formal definition of contract, we call it as an exchange of promises. It's a instrument that allows you to exchange certain set of promises. I promise to construct a building for you, and you promise to pay me something for the effort that I'm going to put in constructing the building. So there is an exchange of promises. I promise to deliver some materials to you. You promise to pay me so that I can deliver that materials to you. So there is an exchange of promises. So contract is nothing but an exchange of promises. And when it comes to construction projects, these exchange of promises comes along with certain description. That is, see, if it is a simple selling of an iPhone or selling of a normal mobile phone, I go to a shop, I pay money, I buy the cell phone, and I come home. So the transaction is completed. Although there were exchange of promises, it's a very simple transaction that doesn't need elaborate written documents for us to complete this transaction. Although there are invoicing and other things, it's a very simple transaction. Imagine you're talking about construction of a building. There are so many things in construction that cannot be just like that discussed verbally or orally and exchanged promises. Although verbal contracts are valid as per Indian Contract Act, but it's not practical to have a verbal contract for constructing a building that contains so many details and nuances. So therefore, there is a scope. This contract describes the scope of work. Now, if I'm a client and I want a building to be constructed and I want Akansha to be and if Akansha is my contractor who is going to actually construct this project to me, then I need to describe to Akansha as to what is it that I want, what is the scope that I expect Akansha to do, right? So that is what we call it as what to do. That is, contract defines what to do in the project. That's the scope. So contract also defines what not to do. See, I want Akansha to construct a building for me, but I don't want Akansha to construct a compound wall for me. I will hire some other contractor to construct compound wall, or I have some other ideas about compound wall. Or I want Akansha to construct the civil part of the building, but I don't want her to supply the AC ducts for me, HVAC ducts for me. Don't do her any, don't want her to do any plumbing works. So there is something I don't want her to do also. right? So some things I want Akansha to do, some things I don't want her to do. Like for example, if we go for a tour package, if you're asking the tour operator, give us a quotation. Tour operator will give us a quotation, and in that quotation, they will say what is included in the package, what is not included in the package, right? So how this hotel local transportation is included, but what is not included is the payment towards parking fees, local visiting charges of certain monuments or buildings or temples or any forts that you are visiting. So there are certain inclusions and exclusions. So similarly, contract comes with what to do and what not to do. So when I say what not to do, there are two kinds of what not to do. One is something that is not acceptable. Okay, something that is not acceptable. And secondly, something that is not required. See, what is meant by something that is not acceptable? That is, if let's say, for example, I want the contractor, I want Akansha, who is my contractor, to Mr. Shailendra Prasad, can you please mute?
Yeah, sure.
Can you please mute? Okay. So something that is not acceptable in the sense, say, let's say, for example, I will tell Akansha that you have to construct this building in 1 year. You have to construct this building in 1 year, and I am not going to permit you to construct this building beyond 1 year. So constructing beyond 1 year is not acceptable to me. This is something that I'm going to put in my contract. Also, I'm also going to put in my contract that I'm not going to allow you to construct anything beyond 5 p.m. in the evening. You cannot construct anything on on non-working days or weekends. So I'm going to put certain restrictions because I'm going to define certain behaviors that I expected from the contractor, saying that this is what I allow you to do. This is not something that I will tolerate. So I'm going to put this. Of course, I'm not use this language there, but I'm just trying to say what is it that is not acceptable to me as an employer. And I also say something that is not required. That is typically scope limitation. That is one of the examples that I told you earlier. I may not want you to do the HVAC works. I may not want you to do the compound wall work because there are certain limitations that I have there, and I have some other plans for that. So I don't want you to do that. So what not to do has something that is not acceptable and something that is not required, what we call scope limitation. Then contract, in addition to this, also says, what if one does what to do, one does not do what to do? Because see, I expect Akansha to do certain things. But what if she does not do as a contractor? Or in other words, Akansha expects me to pay her for the work that she is doing. What if I don't pay her? I expect Akansha to complete the first milestone within 3 months. But what if Akansha doesn't complete the milestone in 3 months? So these are the questions that come, right? Because see, when I say contract is an exchange of promises, you should also think about a situation. What if one breaks the promise? Because in life also we make so many promises to so many people, but we break many promises, right? So the result of that is somebody is unhappy with us or somebody is sad about us. That's a different story. But here, when it comes to commercial transactions, making promises, you should also think about what happens if the promises are broken. That is again what is defined in the contract as to what will happen if one does not do what to do, right? And what if one does what not to do? That is also worried, right? So I'm telling you not to delay the project beyond a year, not to take the time beyond 1 year. Time is the essence of contract. I'm telling you that, but you go beyond 1 year. So I need to have something in my contract that will stop you or prevent you from not doing what you're not supposed to do, right? Something that discourages you from not doing from what you're not supposed to do, right? For example, in contracts, we have something called liquidated damages clause, which says that if you do not complete within so much time, you will have to pay, if the delays are attributable to you as a contractor, you will have to pay certain damages or the certain penalty for delayed completion. So this is a repercussion of what will happen if you do what you're not supposed to do, right? So that is something that is you're doing something that is not acceptable. Then I have a clause in my contract that says what is going to happen to you because you have done something that is not acceptable to me. And in case I want you do something that is not required, that is something for I told Akansha that I don't want you to construct my compound wall. So, but Akansha constructs the compound wall. Then what to do? So these are the situations. Or initially, Akansha was not supposed to construct the compound wall, but let's say I ask Akansha later to construct a compound wall, which is not as per the contract. So then what will happen? So we typically call this as variation to the scope of work. So that clauses are also there in the contract. So basically, contract defines what to do, what not to do, and what if one does not do what to do, and what if one does what not to do. So this is something that you have a contract for. And the beauty of contract is all these things are fine. We can write down in a sheet of paper and we can sign it. But the beauty of contract is once the contract is formed in a manner that is defined in Indian Contract Act 1872. For the sake of time, I'm not getting into the details of Indian Contract Act, but there's an act, there is a law as to how a contract has to be formed. And the moment the contract is formed, the way it has to be formed, the beauty of this is all this becomes legally binding. All this becomes legally binding in the sense, if you are not, you're agreeing on this as a legal agreement, which means that you are bound by this. So if you have made a promise to do something, you have to do that. If you have made a promise not to do something, you should not do it. And if you do it, there are certain repercussions that you have agreed for will happen. You cannot say that, say for example, I told Akansha that she has to complete the entire project in 1 year and I will not tolerate any delays. But Akansha delayed. And the reasons for the delays, Akansha itself, she has not done the work the way she was expected to do for whatever reasons that may be attributable to Akansha. Okay. And that delay is not something that I'm going to tolerate. And therefore, I have a penalty clause in the contract, which I will invoke. And Akansha now cannot say, no, sorry. I thought I will be able to do it, but I could not do it. I will not pay any penalty and all. No, Akansha cannot say that because she is legally bound to pay the penalty because this is something that she has already agreed in the contract under what if one does what not to do. That is not something acceptable to me. And this, she has legally bound to do this. And if she does not do in spite of that, I can take her or I can take the contractor who is not willing to do what they have promised to do or will not willing to pay penalty for having done what they're not supposed to do. I can take them to the court. I can take a legal action. So I get a protection. I get a legal protection. So therefore, contract puts down your expectations of both the parties and also provides a legal protection such that the party who has promised will think twice before they decide to breach the contract. Like before they decide to not to fulfill the promise, they will think twice. And that is the power of contract. That's the moment you sign a contract, you get certain seriousness. You get certain legally binding agreement. Right? That's what contract is all about. See, let's say, for example, I have a friend with me, and I go to my friend and I say, hey, can you lend me 500 rupees? If the friend lends me 500 rupees, I take it and I promise him that I'm going to give this 500 rupees back to him after 10 days. No, my friend doesn't trust me. So my friend gives me a sheet of paper and says that you sign in this that you're going to give me back this 500 rupees in so many days, in 10 days. The moment he hands over this paper to me, I will probably look at him with a face wherein I'll ask him, "Don't you trust me so much at least here? Come on here." Right? Why? Because when I'm asked to sign on something, automatically my mind says, be careful. You're putting your signature, be careful. Why? Because when I'm signing on something, I'm binding myself to it. And I cannot, it's not a child's play. I cannot say, no, I simply signed for a joke or something like that. So you are binding yourself to what you're signing on. Therefore, automatically seriousness comes into picture. So the beauty of contracts is that it is a legally binding document and it can reinforce certain behaviors which as a signatories of the contract, I expect you to do. Right? So that is the power of contract. This power of contract is something that we are going to use to bring in sustainable construction practices into projects. Otherwise, people will be hesitant to implement it in projects because there is nothing binding them to go for sustainable construction practices. But if it becomes a part of the contract, then you cannot say no because it becomes legally binding that you will have to do that. Right? So How does it happen? So how can we use the construction contract to bring in certain good practices to make sure that the construction projects move towards sustainability? Let's take the first example that is there on the screen here. Let me highlight that. So we are talking about exploring alternative sustainable construction materials. We can see how construction contract can play a role in bringing in this practice. So let me tell you this. See, we are all from academic institutions, right? So as a part of our academic institutions, as a part of our day-to-day academic exercises, research is a very important component, right? We keep on working on so many new ideas, especially our colleagues in the materials side. They do a lot of concrete testing. They do a lot of new mixed designs, which are aimed at improving the properties of concrete. So here also in IIT Madras and most of the institutions, you keep on working on new inventions that will help the world to be a better place. Specifically, when I talk about materials researchers, concrete construction materials, concrete researchers, they are known to come up with innovative mixed designs that can actually make concrete better material with every kind of new mixed design. Right? So you can have concrete that you call it as rapid hardening concrete. You have ultra lightweight concrete. You have foaming concrete. Then you have self-compacting concrete. Whole range of different sustainable concreting alternatives. A lot of my students here, that is my students of my colleagues from the material side, they work on sustainable concrete, right? So they are trying to come up with mixed designs that replaces conventional cement with more sustainable materials to make the entire product less carbon intensive, less prone to carbon footprint. So they're coming up with a lot of alternative materials. Quite successful in that. They're doing some kind of mixed designs. They're doing some casting some cubes. They're testing it, and they're coming up with interesting results. They're publishing in various excellent top-notch journals. They're getting international appreciations. They're presenting in conferences. Everything is good. And most of us here are doing that, right? As a part of our academic exercise, we're all good in doing in coming up with these new ideas and innovative ideas and publishing our research and taking our academic profile further. But if you again question how much of this laboratory generated alternative materials to conventional non-sustainable concrete has actually been implemented on field, it is very little. It is very little. Even today, all major construction projects, if you look at, we use conventional OPC or even sometimes even I've heard that many clients are even hesitant to recommend PPC cement. That is Portland pozzolanic cement, right? So you call it not from the material side. So I might be wrong on certain terminologies, but PPC and OPC is something that I have heard a lot when I was in the construction field, and even now I keep hearing from the research students that they keep talking about it. There's a lot of hesitation even to recommend PPC also in the place of OPC. Everybody is happy with OPC. OPC is not a very sustainable material. We have a lot of alternatives to that which are more sustainable. But even then, the majority of the construction projects are still going, or mainstream construction projects are still using OPC. Maybe I'm not saying that everybody does this. There can be few contractors or few clients that are going ahead with more sustainable alternative. But I'm talking about the mainstream or the bulk of the consumption is still the conventional cement, conventional steel, and conventional materials. So the question is, why is it that we are not able to convince our industry partners to adopt these kind of new, innovative, sustainable construction materials? So if we put this question, suppose I go to some large construction company, I have a mixed design with me that that is supposed to be more sustainable alternative to the conventional OPC concrete, OPC cement that we use. I go to a large construction company and I show them that this is a mixed design for the alternative material. Why don't you use it? The first reaction that they would say is that how much does it cost? Right? What is the cost of this particular material? Because I'm my supply chain for OPC cement is quite set. I know how to produce concrete from OPC cement. All my resources are set to produce concrete. Things are going on well. Why should I change? And that too, okay, I will change probably. Why should I change with a material that is actually costlier than what I'm doing right now? Because whatever we try to do in the laboratory scale, definitely it's going to be costly because We are going to use materials which may not be available in bulk outside, and we are only doing on an experimental scale. So definitely it's going to be slightly costlier than the bulk manufacturing or bulk production or bulk preparation of concrete that can happen with the kind of projects that we are talking about. So it's going to be costly. Now, if my concrete mix design has to be economical, then it has to be used by large number of construction companies. But if it has to be used by large number of construction companies, it has to be economical. So now we are entering into a kind of a chicken and egg problem, right? I want you to use it, but you want it to be economical. But unless you use it, how can it be economical? Right? So this is a kind of a vicious cycle that we are caught in, and we are unable to proceed further except for certain situations where people think differently and go ahead and implement certain sustainable practices. So this is where we are stuck, and this is where contract can actually bring in the right behavior. Let's say that I'm stuck in this vicious cycle of who will use it and how will it become economical. Now, let's say that I go to a client, right? Like say CPWD or like say Military Engineer Services or NHAI or Steel Authority of India, some clients like that, just to name a few, I'm just saying. And I go and tell them that, boss, this is a sustainable construction alternative material. This I replaced so much X percentage of cement content with more sustainable materials. And this is something that we have tried in our lab, and it works out, and it meets all the required concrete properties that is required for that, for the structural design and all those things. All those things I show it to that person. Now, to a large extent, at the government level, state government as well as the central government level, it's a huge push towards adopting sustainable construction practices. So maybe because of that, client might be a little bit interested to buy our idea. We will say, okay, fine. I am doing a small project. Maybe I will use this particular material on a pilot scale, and we will see how it comes up. And if it comes out well, then probably we will recommend it in our future projects. But before even they can actually implement that in their project, they'll be asking another question. What is that? Now, see, you are coming with your college approved, lab approved mixed design. Trust it. Very good. But ultimately, this particular design was developed in your lab. Was it tested on field? No. I am the first one who's going to test on field. Why should I be the experimental person? Why should I become the sacrificial goat here in this case? Why should you try it out with my project here? Right. So why don't you do this in your own college construction projects? Demonstrate it and then come to us saying that we have constructed this building and this building is standing very nice and there is absolutely no problem. Then come to us, then probably we'll use it. Why do you want to preach to us before you practice? So therefore, it happened. And therefore, in many of the construction projects within the campus that we construct here, we use some of the alternative materials. But for us to use these alternative materials, one thing that the site engineers here within the campus for construction that they ask is, what are the specifications for these alternative materials? Right? See, mixed design, proving the compressive strength, tensile strength, and all that stuff in the lab is one thing. But how do we actually use this material at site? Practically use this material at site becomes even more important for a site engineer. Site. And that is actually defined as a part of your construction specifications. So this triggered us to understand that it is not enough if we convince people to use alternative construction materials and give them the mixed design. We should also give them kind of a specification document that will help them to convert this particular mixed design into something that is practically doable at site. Like, for example, what does this construction specification have? Like if you take any CPWD specifications for concrete, it will talk about water quality. It will talk about what are the IS codes, what are the permissible limits of certain things in the water, what should be the aggregate quality, what should be the cement quality, what should be the cement content, what should be the mixing process, what should be the transportation process, what should be the curing process, what should be the vibration process, what should be the curing process, what should be the finishing process. So all these things are very beautifully explained in construction specifications. And this document is something that will actually trigger people to use alternative construction materials that are taking us towards sustainable construction practices, not the money part. Because earlier it was money part, but the money part is not a problem now because there is a huge push by the government to go with sustainable construction practices. So people are ready to experiment. But what you need to give them is not just mixed design to prove laboratory-based tests, but to also practically feasible construction specification document. And this specification document is typically a part of the contract. Now, if this document can be drafted along with all materials that are actually being produced in the lab, it will be easier for us to push it through organizations for them to implement in their projects. So the move towards green alternatives is going on, but you can improve the speed by developing the right specifications. And that is what at IIT Madras we are doing constantly, that for all the lab-based materials that have been developed, we are working to develop certain construction specifications to ensure that along with the mixed design, we also give the specification to the industry so that they can actually use it. And how do we do this specification? By implementing these alternative materials in some of the internal projects, by looking at it, by involving our research scholars, involving our students to see how this material is being used outside, what kind of specifications can be developed. And also, developing specifications for new and innovative materials is not a big task because we already have the base specifications for normal concrete. For special concrete, you need to alter certain things. And that's what happens when we support specifications for special concrete. So we got existing specifications and that can be done. It's not a very challenging task or something like that, but it needs time. People have to actually be on site, see what is the problems that are facing, wait till the concrete is completed, and also wait after the concrete is completed for certain duration, at least till first rainy season, to make sure that things are okay. So these are the things that you need to do. It needs a lot of research-based approach, and that's what a lot of students are doing in our IIT Madras. So the first alternative that I'm talking here, that is exploring alternative construction material, is something that can be, the process can be fastened if we can develop some kind of construction specification documents along with any new alternative materials that we do in academia. That's one part of the story. Now, the second part of the story, that is, how do we make sure? So this is about the material part. But now coming to the processes. Now, before I go to the next part, are there any questions till this point with anyone? Anyone wants to ask anything? Was anything not clear? Or if you have any questions, quick questions at this point, we can take it. Otherwise, I'll go ahead further. Any doubts? Any questions? Okay, so there are no, looks like there are no questions, but you can use the chat box to put on your questions in case you want to ask any questions. Okay, right. Let's move on. Now, the second thing that you can see here on the screen is your alternative processes to improve project performance or to improve productivity, work productivity. One is the material part, other is the process part. Now, what is wrong with our processes? What is wrong with the way in which we are actually delivering construction projects? Can anyone tell me? Can anyone quickly share with me, according to you, what is wrong in the way in which we deliver construction projects? What could be the reasons? Or what could be the shortcomings in the way we execute our projects, the management part? What is wrong in that? Anyone? Yeah, I think there's somebody using the chat box. Let me see. Yeah, so Akash has said, we try to finish it quickly. Very good. So we try to finish it quickly, but ultimately, do we achieve that? It's the problem, right? We try to do so many things, we expedite. There are so many roadblocks that is actually preventing us from doing it the way we have wanted to do it, or with the way, or completing it early. So that is a problem. Anyone else? We are compromising on quality, right? So again, Dr. Vidya also says that there's a silo working environment. That is, we don't really bother about working as a team. We just look at our construction is a teamwork. It's a team process, right? We cannot just like that look into the individual deliverables, and that doesn't work like that. Construction doesn't work like that. Excellent point by Dr. Vidya Kanapure. Okay, any other points anyone can put it down, but these are some of the very important points that you all have brought out here. And my next slide is going to be something about that. Yeah, Dr. Suryadev Singh talks about planning and monitoring, and that's exactly what I'm going to talk about in my next slide. If you look at the way construction projects are actually executed, just give me a second. Yeah. sorry. Yeah. So if you look at the way construction projects are executed, there is a fundamental problem. Now, what you see on the screen is something that is quite interesting. Some of you might have already seen this, but this is a very interesting data that talks about the time and cost performance of our projects. And this is particularly projects that are done at the central level. Only certain projects which are, I think, the value 150 crores and above. You find this in the report of the Ministry of Statistics and Program Implementation, MOSPI report, what we call. And look at these numbers. If it is time overrun, roughly 41.51% of projects suffer from time overrun. So this is, yeah, 41.51% the projects suffer from time overrun, which is really, and I'm here, I'm talking about 1,500 odd projects, roughly, which is about 600 projects suffer from time overruns. And this time overrun, as I discussed with you some time ago, is directly contributing to unsustainable construction practices by affecting the way of life and also the regular traffic and affecting the sustainable development goals that we have actually promised ourselves to. Also, in terms of cost, roughly 20% of the project cost is being suffered as an overrun. In terms of numbers, this roughly translates to 4.5 to 5 lakh crore rupees. That's the cost overruns. Even if I really don't bother about cost overrun at this particular point, I'm more concerned about the time overruns, which is really huge, and that is having a huge impact on the way I deliver the projects and the sustainability of construction projects. And if I look at some of the reasons why this is happening, there's a delay in obtaining statutory clearances, delay in finalizing the detailed engineering, there's a delay in tendering, delay in technical approval, contractual issues, change in scope, problems in planning and execution. A whole lot of reasons. I have just mentioned very few here for the sake of discussions in the class, but there are a whole lot of reasons why projects actually get delayed. And if you, in fact, so most of you we are all academicians and researchers. You might have seen a lot of research papers that talk about the causes for delay, the reasons for delay. And if you look at this, both client as well as the contractor are responsible for delays in most of the cases. And also, there are certain beyond control, like force majeure conditions, that are responsible for delays. So, a whole lot of things actually contribute to the delays in the project. And it is important that we take steps to control these delays. That is, delay in obtaining statutory clearances, delay in finalizing detail engineering, delay in tendering, delay in technical approval, contractual issues, change in scope, and problem in planning and execution. That's exactly the point which the other gentleman was saying. Um, this is something that we need to control. Now, how do we control this? Very easy to say, don't delay. Very easy to say, don't don't change the scope. Do proper planning, do proper execution. All very easy to say, but how do you do that? Because only when you control this, the project delay can be controlled. Because delayed projects impact sustainability, and this is where I am introducing you to the concept called lean construction. A solution for all these delays, which according to me is a powerful solution, is what we call it as lean construction, Lean, lean construction. And this construction technique, lean construction techniques, that if we follow in projects, we can actually reduce waste. And the waste here is one of the waste here that we are talking about is the delay. And delays can be reduced if we are putting lean solutions into the project. Now, some of you might be thinking, what is lean? Many of you might be already knowing about lean construction, but I just want to bring in the concept of lean construction here with you all, so that you are, you might be knowing about it, but even then, I'm just going with some kind of basics that will help us to bring us on the same page. What is lean construction? Because understanding lean construction is important, because that is only now going to help us in reducing these problems, and reducing these problems can take us take our projects to more sustainable practices. So therefore, what is lean construction? Now, lean construction is nothing but identifying certain wastes that doesn't contribute to the project productivity and eliminating the waste if possible, or if elimination is not possible, at least try to reduce these wastes. At least try to reduce these wastes. When I say waste here, the waste that I'm talking about here is not only material loss, it is about time loss as well as value loss, right? So, like for example, let me give you some examples. Let's say that you're in a project, okay? Let's say that I'll take the example of Akansha because that's a familiar name here for me, so I'm just taking Akansha as an example, but it can be anybody in that place, okay? So let's say Akansha is my contractor, okay, and I am client. Now, as a client, I want to see progress in the project. That is, every day when I come to the site, when I visit the site, I would like to see that today this column is completed. Tomorrow, one more column is completed. Day after tomorrow, slab is casted. After that, the second floor is started. After that, third floor is started. I would like to see this progress happening day in, day out when I visit the site. But when I actually go to the site, there was progress that was happening from the last week, but from the last 3-4 days, I see that nothing is actually happening at site. Like, I can't see a new column coming up. I can't see a new foundation being casted. Can't see a new slab being casted. But I am seeing that people are quite busy. Right? They are doing something, but it is actually not contributing to the final product that I want to see as a customer. That is concrete. That is the structures being erected there or structures being constructed there. So when I call Akansha and ask Akansha, hey Akansha, what is happening here? From the last few days, I saw very good progress, but from past 2-3 days, I'm seeing that there's no progress. I'm not saying that you're not working. You're working. You're sincerely working. Your people are there here. Workmen are working. I can see equipment doing some work. But I don't see the progress or I don't see anything being constructed or built. And that's actually worrying me, Akansha. What is the problem? Now, what Akansha says to me is, sir, actually, yesterday, fully, we were actually placing the formwork. We are fully placing the formwork. In fact, for the past 2-3 days, at multiple locations, we are actually placing formwork. And once we complete placing the formwork, sir, and we check that, from day after tomorrow onwards, for the next 3 days, we are going to continuously pour concrete, sir, because we have created the front. Now, although Akansha tells this, I'm happy about it. I'm actually not quite happy that from the last 3 days and as well as the next day, that is tomorrow, today, and tomorrow, literally 5 days, there is no work that was done. Although there is work done for me, work according to me is not done. Although Akansha gives me the reasons that she is putting reinforcement and she is placing the formwork, I'm actually not happy unless and until I see concrete structures coming up there. So, in my view, actually what Akansha is doing for the last 3 days and what she is going to do the next 2 days, for me, it is actually not value adding, but it might be required, but it is actually not value adding, right? But what is going to happen after 2 days, that is pouring continuously concrete for 3 full days, that is actually value adding for me because that is actually resulting in some kind of progress that can lead me to the next step. There is some kind of non-value adding actually that is happening. So now I call Akansha and say, hey, why are you spending 5 days in tying in doing this reinforcement and formwork work? Why don't you every day keep pouring on concrete? So Akansha says, sir, how can I do concrete every day, sir? There's a preparatory work also that I need to do. Now I tell Akansha, hey, is there no other way in which I can do this preparatory works in parallel to the concreting works that I'm doing? Can you do that? Is the question that I'm asking Akansha. Okay, so in the site. Now, this is the general question I'm asking you. Is there any way in which I can make the preparatory works also the construction both parallel? Is there any way that I can do it? Any ideas? Is there any ideas? See, I don't want to wait for 5 days. I don't want to wait for 5 days without doing concreting. Every day, I want to see a structure that is being erected inside. But in parallel, the preparatory works for that also should be going on, but concreting also should be going on so that I really don't find any non-value adding activities in my site or non-value adding but necessary activities inside, but I see only value adding activities in my site. What can I do then? What can I do for that? Any ideas? Any thoughts on this? This is something that we commonly adopt in projects. Precast, excellent. Precast, right? Joyce and Silva. So, Akash Prava Panda, quick setting cement. So, these are some of the ideas. That is, I make these things in parallel. They get into the project so that every day I keep on seeing progress. That is precasting. That's exactly precasting what we see on flyover construction and things like that. So, this concept of precasting came because I don't want to see any non-value adding activities in my site, right? So this exactly is the concept of lean, that is trying to see what is actually not value adding to my customer, trying to eliminate that something that is not value adding to my customer. Another example that I'll give you is, let's say for example, I'm a contractor and Akansha is my client. I'll do a role reversal for some time. Why should Akansha be the contractor every time? I will be the contractor and let Akansha be the client. Now, for some reason, I don't think today I'm going to do any work. There's no concrete going to happen. But I know about Akansha as a client, she's very concerned about the progress. So I know she will come and ask me, hey, Murali, I'm not seeing you do any work today. At least last time I was doing some form work. I'm doing some time, some reinforcement. There was non-value adding, but she knows that it is non-value adding, but it is required. So she was happy and she went away. Today, I don't even have that form work tying work, form work placing work also. I don't have reinforcement tying work also, no concreting works also. She comes, she will ask me, why is it that no work is happening and I'll be in trouble? So I want to show her that I'm doing some work. So what I'll do, I will just call some 2 transit mixers. I will tell the batching plant to fill the transit mixer with some concrete, and I will ask the transit mixers to keep on going in the site. As though it is very busy, like we do now many times. I think when we were small children, when our parents come to check if we are studying or not, suddenly we take a book and start reading the book, right? So I'm sure that that time we will not be doing any reading, but just to make sure that our parents are happy that we are doing something, we start reading. But it is absolutely waste that what we are doing at that time. Nothing is going to go in our brain. Sometimes we keep the book on the opposite direction and read, and we get caught. So this is all not value adding, and it's just to show off. Similarly, going to pour concrete in a truck, and I asked the truck driver to take that transit mixer and keep on roaming in the site. Maybe small works here and there, you put concrete, but you keep on roaming in the site. Is this value adding? Definitely not. It is a waste. It is purely non-value adding and not required, right? So there are so many activities in the project that are actually not value adding and not required. And some other examples is when you go to a site, when you actually walk in the site and you can see workmen or workers doing some work, you will see that they're simply standing and chatting. They're not doing anything. From past 10, 15 minutes, they're simply standing. If you go ask them, why are you standing? They will say, Saab nahi aaya, means boss has not come. They have not given me instructions. I don't know from where material is going to come. Or I will see that to get one mortar pan of cement, a person will walk about a kilometer. Aram say for half an hour, they will walk and they will get one mortar pan of cement and they'll come and pour. This is purely the problem of logistics of the site. I do not keep my resources and so raw materials at a place which is closer to my construction. So I spend a lot of time in moving people and moving materials, which is absolutely not adding any value to anyone, neither to Akansha or to me as a contractor, neither to Akansha as a client. So these are non-value adding activities. Now, lean construction comes up with this concept of identifying the various wastes in construction and coming up with processes and procedures to eliminate this waste. And if elimination is not possible, at least to mitigate these wastes, to reduce these wastes. And there are so many ways to do that. How do you identify waste? There's something called value stream mapping. There is something called foreman delay survey. There is something called crew balance chart. There is something called work sampling. So there are so many different methods, very interesting methods. See, lean construction is actually originating from lean manufacturing principles. So those who know about lean manufacturing, understanding lean construction is very simple. Because lean construction was derived from the manufacturing concepts. It's an extension of the manufacturing concept. Although lean construction took a different shape and people drove it in a different direction, it has become a subject of its own now. It has its roots in lean manufacturing concepts, the Toyota production systems, and all those things that you might be aware of when it comes to lean manufacturing concepts. So lean is all about identifying wastes in projects and coming up with tools and techniques and methods and processes to eliminate them, or if elimination is not possible, at least reduce them. And when I say waste, it is not only the material waste that we commonly talk about in projects, we also talk about waiting, time-related waste. We talk about transportation waste. We talk about waste, which is wherein we try to do the work much more than what we're actually supposed to do. That is, we are trying to over deliver the work. That is also a waste because that's also going to affect you in one way or the other. Like for example, I'm doing plastering of my wall, and let's say that the masonry is completed. I do the plastering and continuously do it. I was asked to do plastering for one particular section of the wall, but since I get the front, I complete plastering everywhere in the room. Next day morning, I have the electrician coming and doing the chasing work. So unnecessarily, my plastering is done. Now somebody is going to chase it. And when somebody chases it, I will do a repair patch-up work later. So it's all unnecessary. If I was restricting myself to the wall wherein I was given the clearance to plaster, rework wouldn't have come because rework is also a waste. Rework is also a waste. Also, getting materials much before what is required is also a waste. Producing more than what is required is also a waste. You might have heard about the concept of just-in-time delivery. So all these things are one way or other related to lean construction. So lean basically talks about reducing these wastes, reducing non-value adding activities so that the productivity is improved. When the productivity is improved, delays are reduced. When the delays are reduced, project gets completed on time. When the project gets completed on time, its impact on the surrounding environment and on the environment in general can be mitigated, can be reduced, and projects can become more sustainable when the delays are lesser. So this is where I'm coming to actually. Now that we know the concept of lean construction, now that we know what lean construction is all about, and it's all about reducing the waste, it's all about reducing waste and identifying waste and reducing and eliminate waste. Now, the next question you might ask me is, how do I do it? How do I eliminate this waste? How do I reduce this waste? What should be some of the principles that I need to follow to eliminate these wastes, and what makes the project lean? So this is where I'm coming up with my overall framework, and this is on the last slide that I'm going to talk about, but I'm going to spend some time on this, wherein I'm going to connect the concepts that we have discussed till now. That is, the one concept is about the sustainable construction practices. The second concept is about how a contract can help. And third concept is about what is lean construction and how lean can promote sustainable construction practices. Now let's try to see that. That is, what we are trying to say is that to bring in lean practices into the project to reduce waste, there are 7 things that one has to do it. Okay, I spend a lot of time on these 7 things in my regular class, but since this is an FDP, I'm making this summarized and I'm presenting it to you so that you know that we cover the contents rather than getting into depth. And in case anybody wants to discuss more into depth, you're welcome. I'll share my contact details later and we can always talk about it in detail. So collaboration, stakeholder involvement, detailed short-term planning, identifying constraints, pull-based planning, no blame approach, and continuous improvements. These are the 7 key mantras that I would say, if we follow in the project, we can actually implement lean construction. And if we implement lean construction, we can reduce or even eliminate waste. If we eliminate waste, we can improve productivity. If we improve productivity, we can complete projects on time. If we complete projects on time, it is one step towards more sustainable construction project that we are talking about. Okay? Now, what are all these things? Right? Some chat. Okay. Collaboration. Now, collaboration is an English term, collaboration here. Now, see, we need to remember that ultimately the project that we are constructing is a combined effort of various stakeholders who are involved in the project. So often we tend to see client and contractors as 2 opposite parties, right? Client and contractors as 2 warring parties. They don't like each other. They keep fighting with each other. That's the typical idea that we get when we talk about parties to a contract. But if we look at it that way, then we are never going to achieve projects completing on time, because one will always try to pull the leg of the other. I, as a client, would always try to protect myself and my interest and would try to put all the blame onto the contractor. Contractor on the other side would try to protect their interest and they try to put the blame on the employer. So we will never collaborate, but we'll always be against each other. And we'll always try to see how we protect ourselves rather than achieving the goals of the project. But lean says, forget about your goals, look at the project goals, and if you achieve the project goals, you will automatically achieve your goals. In fact, lean talks about risk sharing concept. I will talk about it in a short while, but it's a very simple concept that if you work together, like Vidya madam was telling about silo working, this is exactly not supposed to be done. So that is something bad. That's what she was saying. So collaboration is opposite to silo working. So when I work in project, I make sure that I work along with my team and I deliver it rather than me looking at individually, because looking at individually is not going to help in any way, because that's not going to lead to the goals of the project. Then stakeholder involvement. Now, who are the various stakeholders in the project? You have the client, you have the contractor, you have the subcontractor, you have the designer, you have the architect, you have the vendor, you have public, you have government. There are multiple stakeholders, or the people who are actually interested in the outcomes of the project or interested in the way a project is constructed and delivered. Now, unless these stakeholders are involved, you will not be able to deliver the final outcome. Now, how many times in a project do you involve the client in your decision making? We always, I'm just telling you as a practice, I always at site try to keep my client away and try to take decisions which within myself, within my organization. We want to keep the client away. And similarly, the client wants to keep the contractor away and try to take certain decisions. This is not going to help the project because you are not looking at a common goal. You're trying to just protect your position, safeguard your interest, and that is never going to help in achieving the project. See, it is something like when we give assignments to students, we can easily come to know whether this assignment is a teamwork or an individual's effort, right? So we have our own methods, right? We ask randomly one person in the group to come and present. If they are not able to present, it is sure that that person has not contributed anything in the team. And this is only one person. And also in many assignment cases, you would have seen one person is so dominating that they don't want others to learn anything. They will take all the work and they will do it and go away. That is also not good. That is also not good. You're not allowing your team to get involved into the project. So we can easily identify those assignments and we'll easily be able to reduce their marks because their assignment is not of good quality. Similarly, a project that doesn't involve stakeholders is not of good quality. Then there's something called detailed portfolio planning. Just a minute. So there's something there's always something called planning, right? So we plan for the activities that is going to happen in the future. Now, generally, when we and to start with in any projects, we have something called baseline planning. We have a plan that we prepare, right? So for the next 1 year of the project, what is the plan or what is the sequence of activities that we are going to do in MSP Primavera prepare this? Many times you might have observed that we take a lot of time in preparing this plan. The baseline plan, in fact, in many projects takes about 2 to 3 months for it to get approved from the customer. Right? And why it takes so much amount of time? Because I get into a lot of details. And not details with respect to the work that I'm doing today and tomorrow, but details with respect to the work that I'm going to do after 1 year or after 2 years. Let's say the project is 3 year duration. I go to such an extent that I even plan for an activity that is going to happen after 2 years on 3rd September 2028 at in the morning 8 o'clock. What activities should be going on? To that extent, we get into the details. Now, the question that we are trying to put here is that, or what Lean framework puts is that, is it really required to put so much effort in such a long-term planning? Instead of putting so much effort in long-term planning, put some effort in detailed short-term planning. See what work has to be done tomorrow. See what work has to be done this week. See what work has to be done in next 1 month. See what work has to be done in next 6 months. Don't worry about what is going to happen after 2 years. It is beyond your control. See, my friends here, those who have seen at the project sites, you will agree with me that project sites are so dynamic that you cannot even predict what is going to happen tomorrow morning. But why are we really spending so much time in developing a detailed schedule for 3 years when actually everything is going to change in the next few days? So Lean says, put all your energies in the short-term planning rather than putting so much of energy in the long-term plan. But that doesn't mean that you should not have a long-term plan. You should have a long-term plan. You should have a milestone. Leave it there. Get into the details for the work that you have, that you can control, that is there in your hand. Then the next important concept that Lean puts in is identify constraints for the work that you're doing. See, many times what happens is, like, let's say we have concreting work. Let's say I want to pour concrete for my foundation. Now, what are some of the steps before concrete is poured? At site, if you look at it, first of all, I need to prepare that base with PCC. Then I need to finish my form work, reinforcement, then form work. Then I should ensure that the spacing between the reinforcement is correct and the cover blocks are placed. The inside is everything is cleaned. The entire reinforcement is as per the drawing. The lines and levels are checked. Then lighting arrangements are made. Safety requirements are fulfilled. The concrete is ordered in the batching plant. There are a whole lot of preparatory activities that has to be done before actually concrete is poured. Then the safety inspector should come and inspect and approve. Quality inspector should come and inspect and approve. Then the client's PMC should come and approve the pour card. Client should come and approve the pour card. Then after all these things, your transit mixer will come, and if weather permits, then you will actually start pouring concrete. Now, once concrete is started, generally it won't get delayed because you cannot stop concreting in between, right? So once the pour has started, pour should complete. even if it rains or whatever it is, we take adequate protection to ensure that structurally it is not damaged, and we continue our pour. But whenever the concreting activity is delayed, the blame is on concreting. Actually, the problem is not with concreting. You might not have started concreting because the safety inspector did not come and inspect it on time, because there were some mistakes in the drawing, because some subcontractors are supposed to put some MEP sleeves and they did not do it. So these are some of the preparatory works that actually got delayed, which actually led to delay in concrete. But nowhere this gets recorded because you never identify these preparatory works in my schedule. We only say 10 days concreting. But in 10 days concreting, 1 day might be concreting, 9 days are preparatory works. Or you break that into multiple days, you have preparatory work, concrete, preparatory work, concrete, preparatory work, concrete. Preparatory work is not identified anywhere in your schedule. You only say 10 days concrete. No, if there's a delay, you blame the concrete. But poor concrete, it is not getting delayed. It is the preparatory works of concrete. The constraints that is going to stop you from starting concrete, those constraints are actually getting delayed and they never get identified. And because they never get identified, they never get controlled. And this problem of the number of safety inspectors not being sufficient at site, that is actually delaying the start of the pour, it will not come out so easily, because this problem will come out only in the end, when there is no other way. Because see, nobody at project site wants to give a wrong information or a delay information to anyone, right? Because that will affect your image, that will affect your productivity and other things, right? So you want to try to control this scenario as much as possible. But in the process of doing this, which is good, but in the process of doing this, we're actually affecting the project. So it is important that we identify constraints, allocate responsibility for the people to remove these constraints, and act it closely so that if there's any problem, that gets identified and gets resolved. Another important concept that Lean says is pull-based planning. Now, again, if you look at the project sites, most of the places we talk about push-based planning, in the sense the project manager says, come what may, 400 cubic meter of concrete. I really don't care what you're going to do. This is called push-based approach. Pull-based approach is an approach where you're trying to get the work done by supporting your team member with all resources that are required to achieve that target. Now, let's say that I'm a site engineer and I have my project manager who is Akansha. Now, Akansha tells me that, Murali, you have to pour 40 m³ of concrete tomorrow. Right? You have to pour 40 m³ of concrete tomorrow. Now, if it is push-based, Akansha would tell me, I don't care what you do, Murali, you have to pour 40 m³ concrete tomorrow. If it is pull-based, Akansha's approach would be different. She will tell me, see, Murali, you have to pour 40 m³ of concrete tomorrow. For pouring 40 m³ of concrete, what do you need? Tell me. So I come up with my requirements. I say I want a dedicated batching plant. I want 2 transit mixes. No, Akansha is going to arrange all these things for me as a resource coordinator. And when she gives me all these resources, if I don't do it, then there is my problem. But generally, when I commit and I get the resources, there is no reason for me not to do the work. So this is called pull-based planning, which is also the concept what we call in Lean as respect for people. Rather than pushing things onto people, we are actually making them do it by supporting them. We got our no blame game approach. That is, we always try to suppress problems in the beginning stage and we carry it on to the end stage of the project. And that is where we try to start blaming each other, because in the end stage of the project, we know that there cannot be any repair to the project or we cannot complete the project on time. Now it is the question of blaming other person rather than solving the problem. But if the same problem comes, see, any delay in a project will actually have its root cause much early, right? But we don't tend to discuss this point, because if we discuss, we feel that others will blame us for the delay. But if the earlier we bring out these problems, the better it is, because we get time to solve these problems. Rather than putting blame, we will say, okay, don't blame here, we have time, let us solve the problem. So that blame game approach automatically comes in when we are actually doing things at a much early stage, and also we are and also when we are actually trying not to hide things and trying to come up with facts by involving all the stakeholders. Veena ji, can you please, I think there's some scribbling that's happening on the screen. Can you please stop from doing that? Okay. Then there's something called continuous improvement. We should not be happy about what we are achieving right now. The moment we start following the other 6 principles, we see that we start achieving our targets, then we need to increase our targets to continuously move ahead further. So these are some principles that talk about lean construction. Okay, so doing this actually helps you to implement lean construction in projects. I'm sorry for that. One second. So doing this through a lot of systems like last plan system, 5S, these are some of the tools and procedures through which you can achieve these things. When you do this, you actually implement lean construction on project. And when you implement lean construction on projects, you actually reduce waste, reduce delays. When you reduce waste and delays in the project, you make it more sustainable. Now, in all these things, you might still be wondering, where is contract coming into picture? Look, we spoke about contract, we spoke about the strength of contract. Now, where is contract coming into picture? Contract is actually enabled to implement lean construction. I told you that contract is a very powerful instrument that can help in bringing in right behaviors. Lean behaviors are very nice, but very difficult to implement. That is where contract can help in achieving these behaviors. Now, how can a contract help in achieving these behaviors? I'm giving you some examples, which I can elaborate it, keep on elaborating it, but in the interest of time, let me keep it as short and simple. Now, um, so the contracts, when we draft, they have to emphasize on collaboration, right? So I told that the parties have to collaborate, but it is very easy to say we have to collaborate, but how do you make it collaborate? Like, for example, if you want to do, make sure that the students work on the group project as a team, what do you generally do? Can anyone tell me? Can anyone tell me? So suppose you give a group project or group assignment. To make sure that they are actually working as a group, what do you do? What do you typically do? What do you typically do to make sure that the team works as a group? I have a technique to do, which I'll tell you, but some of you might be already doing that. What do you do to make sure that the team works as a team and not as an individual driven exercise? So you divide the work. That is one thing. Jobil Varghese says you divide the work and say that, okay, you do this, you do this, you do this, and finally come up with the final product. That's one way to do it. And Akash says progress review meeting. I ask them what you're doing, what you're doing, what you're doing. You review that. Divide the work and try to review. Okay, what else? Any other ways of doing this? Okay, so there are multiple ways of doing. What I typically do is I give the work. I tell them that, yeah, targets is another thing. I give the work and I tell them that, okay, achieve this final present, and finally you have to do this presentation. Okay, and you need to finally show this as a final output. Okay. Now, when you make the final presentation, I tell them that I might ask anybody in the group to make the final presentation. By doing this, automatically you're actually getting involved because you have the fear that what if the faculty asks me to present, so let me better get involved into the group. I will ask some person randomly in the group, tell me, how did you get this particular result? Now, if that person is not involved, definitely the person will not be able to tell it correctly. So therefore, automatically, I bring in certain practices to make sure that they collaborate. And similarly, contract documents must be able to bring in this practice of collaboration. For example, FIDIC contracts have this concept called early warning. That is, whenever a client or contractor comes to know of certain specific instances that can actually result in some impact or time or cost, it is contractually mandated to them that they have to alert each other. And if you don't alert, there are some repercussions for that. Now, what I'm trying to say is that the contract has a clause that helps the parties to support each other in terms of difficulties. Another example that I will tell you is that FIDIC contracts, also some NHA contracts, have this amicable settlement clause. Now, when there's a dispute between parties, the first level of dispute is they try to negotiate and close. But if the negotiation doesn't work out, the next step is arbitration. But if you allow the parties to go to arbitration immediately after negotiation, it might lead to the very non-collaborative way of solving the problem, because arbitration is not a very smooth way of solving the dispute, unlike negotiation. But what the contract says is, once the negotiation fails or the dispute review board process fails, you have to give a mandatory 56-day cooling off period. That is, you cannot invoke arbitration for the next 56 days, which means that 56 days you have to keep quiet, nothing doing. So this 56 days, in the 56 days, probably your tensions will come down. You will start thinking more logically, practically, and maybe 56 days, you will try to go reach out to the other party and try to settle the matter rather than taking up in arbitration or a very litigative manner, right? So this is one way in which contracts can bring in the right behavior. And interestingly, I'm not sure how many of you are aware of this. you must read this concept called alliance contracts or something called integrated project deliveries. Although these two things are slightly different from each other, but they are interesting concepts wherein the entire basis of drafting the contract is risk sharing and not risk transfer. See, most of the contracts that we sign is risk transfer. That is, as I explained earlier to you, if you don't do this, you're going to suffer this. If I don't do this, you can ask me to pay penalty. So it is more like, if you don't do this, I will do this. If I don't do this, you can do this to me. It's kind of risk transfer. That is, you are supposed to do this. Like, for example, how we tell our students, right? If you don't do the assignment, I'm going to cut your marks. So that is, the risk of not doing the assignment is actually transferred to the student. Similarly, in construction project, the risk of not completing the project on time is transferred to the contractor, right? So that is the typical way of looking at transactional contracts. But alliance contract is slightly different. What alliance contract says is that, very interesting concept. You may not actually accept this concept readily, but this is something that has been used in Australia in a wide way. Generally, Australia is known for a pioneer for implementing alliance contracting models, wherein it says that in alliance contract, irrespective of whoever is responsible for delay, maybe as a contractor, I am responsible, as a client, Akansha may be responsible, but the delay, if it results in some kind of cost overrun in the project, that is 100 crores was the initial project cost that was thought of, if this 100 crores becomes 10 crores for certain reasons, both client and contractor are going to share the impact of this delay 50-50. Now, I am not going to ask who did this delay, or Akansha is not going to ask me what is my contribution to this delay. We are not going to talk about each other's contribution to the delay, irrespective of whoever has caused the delay or irrespective of whoever has caused the overrun. The impact is shared on the basis of a pre-agreed ratio in the contract. This is called pain share model of alliance contract. Very interesting concept. By this, what is actually happening is, if you as a contractor is not able to progress in the project due to shortage of labor or some reason which is under your control, I will not sit and see the fun. I will make sure that I help you by probably using my sources and getting you some additional support. Or maybe I reduce the scope of work, or I do something to make sure that you as a contractor don't suffer. Because if you suffer, project suffers, I have to share 50% of that. And similarly, as a client, if I am not in a position to give you drawings, if drawing is my scope, in a typical project, you as a contractor would simply write a letter to me saying that you have not given drawings, so all the delays you are responsible. But here in alliance contract, there's no point in you writing such a letter to me. Instead, you will say, hey, Murali, let me help you to prepare drawings, because my delay is your delay and your delay is my delay. Automatically, we are made to work towards the project goal. That is the beauty of this alliance contract. Yes, you might have a question saying that, sir, why should I take the responsibility for other person's delay? Similarly, other person also might feel, now why should they take responsibility for your delay? So this concept is definitely culturally difficult to accept it. But if you accept it, it becomes very natural way to collaborate and involve stakeholders. Because I know that your problem is not going to help me, and you know that my problem is not going to help you. Because I cannot transfer risk to you. See, in typical contracts, let's say even if you take EPC contract, engineering, procurement, and construction contract, you prepare the drawing as a contractor, you give it to me. I approve it, but I don't take the responsibility for anything wrong even if I approve it, because the risk is transferred to you. But if it is an alliance contract, I will definitely involve myself to approve the drawing, check everything properly and correct any mistakes, and I take the blame equally 50%. So I am also involved in the project. I cannot do simply a namesake work and wash off my hands later. That's the beauty of alliance contract. Then um, also have certain tools that can help you for project monitoring and control. See, we use MSP and Primavera in projects. Although they are very good tools, these tools sometimes oversimplify the projects. They make the projects highly certain, whereas the projects are actually very uncertain, right? I am able to control the completion of the project by modifying an activity duration in the future, but in real life, I won't be able to do that, right? So whenever there is some delay in the project and whenever we adjust the durations, these tools must automatically ask for the reason, and automatically the tool should be able to record this reason in the backend, so that tomorrow when somebody is actually looking back at the project, they know that some delays have already been recorded and you will not repeat the same mistakes. And there is a concept called big room meeting. I want you to explore that. This big room meeting concept, when you implement, you can automatically ensure stakeholder involvement and collaborative planning automatically happens. Then you might have heard about this concept called building information modeling. That is three-dimensional models that can help you in actually completing it. Akansha, I'll be completing it by the time that you have told. Okay, 8 o'clock is the time that you have given to me. I'll complete by 8 o'clock. Don't worry about that. Okay. So when I implement building information modeling, I get a three-dimensional image, and we all start looking at the product same. Like and we can also do a class detection to avoid rework. So that is the advantage of going with building information modeling. Then I also have some suggestions regarding how you draft a contract clause. So whenever you draft a contract clause, if it is a clause that requires one party to take certain action, timelines have to be defined. And if that action requires a response from the customer side or contractor side, timelines for that also should be defined. And what will happen if the parties don't follow the timeline? That should also be defined. And many times in construction contracts, there are this one-sided clauses which transfer the risk to the contractors or transfer the risk to the clients completely one-sided. And these are called exculpatory clauses. And these clauses have to be avoided. I've given some examples in the presentation. When I share the PPT, you'll be able to see that. I've just given you a very, very broad overview of how a contract can be used to bring in these lean practices and how lean practices can lead to better reduction in waste, reducing delays, and it can improve sustainability. Okay, so this is what I wanted to cover, and this is the framework which I want to show it to you. And that's all from my side. But if you have any quick questions, we have another 5 minutes. We can take up some questions. I can see in the chat box that there are some questions from So Dr. Bharat Bhushan Jindal, you have asked the question, do litigation don't affect sustainability of project rather than educating the contractor from... See, litigation is again causes litigation. So litigation is caused because of contractual issues. One reason why litigation is caused is because of contractual issues, right? And contractual issues, if they are settled amicably, then why litigation will happen? Okay, so it is definitely we have to avoid litigation that can lead to the reduction in the delays in the project. But to avoid litigation, one has to be aware of the contractual responsibilities, and that is what we are trying to do here. Rather than keep on looking at the contract and trying to safeguard your position and try to put the blame on the others and go to litigation, collaborate and do the work and complete the work on time so that both you and the other party are benefited and the project gets benefited as a whole, rather than fighting litigation and other things. That's the point that I'm trying to say, Dr. Bharat. Yeah, are there any other questions? Any doubts? Any other questions or doubts? Akansha said that there are certain questions, but I'm not able to see any other question in the chat box. Yeah, I can. So has it been implemented in certain places? Yeah, see, some of these clauses have been implemented. Like, for example, FIDIC contracts have been used in many public sector contracts as well. NEC is not so much practiced in India. Alliance contract was implemented in a project in Chennai, but it didn't take off because Alliance contract requires a cultural shift in the way of thinking, because it's a very different way of project execution. Alliance contract has taken up massively in public sector contract construction in Australia. In fact, you can go to Google and type Alliance contracting guidelines, Australian government. You will get a whole lot of data on how Alliance contract can actually be implemented. Building information modeling is generally implemented in most of the projects these days. And these important contracting practices like having timeline defined, defining timelines to respond to a request, all these things are actually emphasized in FIDIC contracts, because FIDIC contracts are contractual templates that are known for its very unbiased way of looking at client and contractor. It's not a one-sided contract. Okay, so many of these things are being practiced. Even lean construction, for that matter, is being practiced by so many contractors in the market. See, for those who want to know more about lean, I would recommend you to visit this website of ILCE. It's called Institute for Lean Construction Excellence. Institute for Lean Construction Excellence, ILCE. If you go to their website, they give a lot of success stories about where lean construction was implemented and what are the advantages of implementing lean construction. It's actually a very interesting website. A lot of data is there, and you can even become a member of that particular organization. It's a very, very vibrant group that wherein lean construction implementation is a focus. Many companies that have implemented lean has actually seen a lot of positive advantages. It is the question of changing a little bit, moving a little bit further and adopting these practices, which requires slightly different way of thinking. And if this right way of thinking is brought in through the construction contract, then automatically you will start using lean in subsequent contracts onwards. Once you taste the success of lean, you will start automatically using in future projects. That's the beauty of lean and contract. Yeah. So what about combination of BIM? Yeah, there is, see, BIM is again improving visualization. And improving visualization helps in increasing the productivity. And anything that increases productivity and brings down the waste is lean construction. Right? So it's all connected. BIM and lean are very much connected. A lot of research articles are there that connect BIM and lean. Any other questions? It's already 8. So if you still have further questions, I can leave my contact details. So this is my email ID and 9663410101. 9663410101 is my mobile number. And my mobile number is available with the organizers as well. If anybody wants to have a further discussion on this, welcome to discuss with you and collaborate with you for sharing knowledge. And that's it from my side. Thank you so much for this opportunity and look forward to future interactions with you all. Thank you so much. Akansha, I'm done.
Yeah. Thank you, sir. Thank you so much for that extremely insightful and deep diving session on implementing sustainable construction practices through improved contract management. We deeply appreciate your sharing your invaluable insights with the FDP participants. Now I'd like to request all the participants to please switch on their cameras so that we can take a screenshot for the same. Okay, it's done. Thank you so much, sir.
Thank you so much, Akansha. Thank you for the opportunity. See you all. Bye. All the best to all of you.
So we now proceed immediately to the second and final session for day 1. While session 1 focused on policy, our next session, running from 8 p.m. to 9:30 p.m., emphasizes the life cycle commitment essential for achieving net zero. The session topic is Role of Structural Audits in Sustainable Infrastructure. It is my pleasure to introduce a highly distinguished civil engineering professional and an expert practitioner in this field, Dr. Ankur Gupta. Dr. Gupta is currently the General Manager at Creative Design Consultants and Engineers Private Limited, CCPL. He brings over 14 years of comprehensive experience spanning teaching, research, and consultancy. His core expertise is directly relevant to a theme, being structural health assessment, structural audits, and rehabilitation of structures. Dr. Gupta has extensive experience in consultancy projects across major infrastructure sectors. Furthermore, he is deeply committed to bridging the industry academia gap, a commitment we highly value at NICMAR Delhi, where he serves as a member of the academic committee. He has delivered expert training sessions to executives from leading organizations such as NSBC, NCRTC, DMRC, and Canara Bank. We look forward to his insights on how continuous assessment ensures our green design efforts translate into long-term performance. Please, participants, be prepared with your questions on structural longevity and maintenance. I now invite Dr. Ankur Gupta to commence the session 2. Sir, the stage is yours.
Thank you, Kansha. Thank you so much for a wonderful introduction. I think like you have said much more about me. Anyway, so can I share the PPT?
Yes, sir.
Okay. So is my screen visible to all?
Yes, sir, it's visible.
Okay. Okay, so like screen is in like full screen mode, or this is a compact mode? So right now you are able to see the full screen or the compact mode?
Dr. Gupta, it is compact mode.
Okay. Is it fine now?
Yes,
Now
now it
fine,
is
sir.
fine.
Okay, great. So like thank you for very much, Dr. Nakul, like for inviting me on this FDP, being a part of this FDP, and express my views, my experience on the structural audit as a part of the sustainable infrastructure. So I will try to like give you the maximum content possible in the short duration of around 1.5 hour. So without wasting further any much time, like let's proceed with the role of a structural audit in sustainable infrastructure. Okay, so like the top this theme of the FDP is digital construction and green design pathway to net zero. So let us first discuss about the net zero imperative. So this net zero is not a buzzword now; it's an engineering commitment. So earlier we may think of it as a buzzword, that how it is possible to achieve net zero, but it is now completely possible through the engineering commitments. So like coming to the construction industry, buildings only, like I will be focusing on that only. So if we see the global share of buildings and construction operation and process CO2 emission as per the UNEP 2022 report, so it is saying that 37% of the global CO2 emission is coming from the buildings and construction operations. Like they have divided it into various direct and indirect sectors, from residential direct sources, residential indirect sources, then again non-residential direct and indirect sources, and building construction, industry, concrete, aluminum, and so and so and so. So residential direct means what? Like we are directly emitting CO2 in the environment. Indirect means like we are using some facilities that are like requiring some sort of CO2 emission in the environment. So this way, like direct and indirect has been like defined. So we can see like from residential buildings itself, we are having a contribution of around 17% of the global CO2. And from non-residential, it is 11%. So if we sum up these two only, so it will be like becoming more than like 20%. So this is what makes the structural audit more important for the buildings, because the ultimate goal of the audit will be to assess the structure and like check its remaining life, so that the decision, informed decision can be made regarding the demolition of the building or to further repair and rehabilitate. So how we can achieve this net zero? Like we are having different stakeholders. First, we are having designers. So what designers they can do? They can reduce by like they can achieve this net zero by reducing the operational energy of the building. Then we are having material scientists who can innovate new materials, who can like introduce the low carbon materials in the building. And then without like expanding the list, I'm coming straight away to the structural engineers, how they can like play a role in achieving this net zero. So the structural engineers through audits, repair and rehabilitation, they can extend the service life of the assets, which will ultimately lead to the net zero. Then second term here is the sustainable infrastructure. So when we speak about the sustainable infrastructure, what we really mean? Generally, like it is linked to the new construction. So we often say that the sustainable infrastructure is all about the green buildings, the new constructions, the new like buildings which are being designed and constructed. We have not like seen the concept of this sustainable infrastructure in the existing buildings as of now. But we can also like serve the society by giving a sustainable infrastructure if we are able to extend the life of the already built environment. If we are able to extend the life of what has already been built, then we in some ways contributing to the sustainable infrastructure. So we all know that any building, bridge or industrial facility, they embodies massive carbon, material, and energy investments. So like if we are able to somehow save a building, then we are indirectly saving a lot of embodied carbon emissions. We are saving a lot of materials, and we are saving a lot of investments also. So we can say like every building we rehabilitate is a step towards net zero. This is for the structural auditors. This is for the structural engineers who are engaged in this field. So whenever we are able to rehabilitate any building, we are actually contributing towards the net zero. So let us now move towards the global scenario of the buildings and bridges in like what the condition says. If we say see the United States, so more than 50% of the buildings they are built before 1980. What does it mean? Like most of the buildings are 45 years of age. So half of the infrastructure, half of the buildings have crossed more than 50% of their design life almost. In the United Kingdom, 79% of the buildings they were of before 2000, means they have crossed 25 years. Similarly, in Germany, 89%, Italy 90%, France 66%, and so more or less what we can see, like in these countries or most of these other developed countries, the age of the building is more than 25 years for more than 60% of the buildings. So if we like see a building in general is designed for 50 to 60 years. So in majority of these countries, the buildings have crossed their two-third life, the 45 years, 45 years, 55 years, 55 years. So when they have crossed their life, after a few years, after 5 years, 10 years, or 15 years, these buildings will become unsafe for use. So the next step will be the demolition of these buildings or the reconstruction of these buildings. But we have a choice now. If we are able to assess these buildings, if we are able to maintain these buildings, if we are able to properly audit these buildings, then through repair, rehabilitation, and retrofitting methods, we can increase the life of these buildings. And once we are increasing the life of these buildings, in some way, we are reducing the carbon emissions from the environment. If you see the scenario in case of bridges in the United States, approximately 36% of the bridges they require major repair work or replacement. As a count, like more than 42,400 rated as poor. So the condition is very poor. So poor condition means either they have to be retrofitted or they need to be demolished and reconstructed. In Germany, around 87% of the road bridges and bridge substructures, they may require rehabilitation, and only 13% are in good or very good condition. In Italy, the road bridges, the collapse is at the rate of 5 into 10 power minus 5 per year. So 246 collapses till now documented in Italy. Similarly, for France, we are having 45,000 municipal bridges which require repair. For Japan, it is expected that by 2023, 48% of the bridges will cross the life of 50 years. So this will indicate a huge need for the repair, rehabilitation, and retrofitting, and before that, the audit of those bridges. In Australia, again, approximately 70% of the bridges are over 50 years old. In Russia, 70% of the capital bridges were built between 1970s and 1990s. So like this data is giving some message, giving some clue for us. Like most of our built environment in terms of infrastructure is getting aged. They're getting old. It is getting old. So it now requires some sort of assessment in terms of its safety, in terms of its serviceability, in terms of its durability, so that the further decision can be made whether we have to demolish the structure or we can continue the structure. If you see the Indian scenario, like this is the data from last few years, basically from 2024 onwards. There are multiple such cases. I have just taken only 7-8 cases. So in May 15, 2025, itself in Ghaziabad, a balcony collapses in Tulsi Niketan residential colony. So that the reason quoted was illegal construction and they ignored complaints. Unfortunately, 2 died in this. Similarly, in 2024 December, in Mohali, Punjab, a 4-story building collapsed. Again, the cause is unauthorized excavation nearby and the structural instability. So 2 dead. In October 24, Bengaluru, and September 24, Lucknow, similarly in Surat, Gujarat, New Delhi, Kolkata. So all these are some of the few of the cases of collapses happening near us. So there are some causes behind this. The main cause behind any collapse is the ignorance regarding its maintenance, ignorance related to its assessment, its audit, and timely repair and remedial measures to be taken for maintaining the building. Very small defects, like we are having some dampness issues, we are having some minor cracks in the building, and we are ignoring them, or we are temporarily repairing them without looking at the root cause of the deterioration. Then after some time, the same deterioration, same defects will reappear. Again, we'll do the same thing. We'll just do the cosmetic treatment over it, and over a period of time, the minor issues, they become major, and ultimately they become a threat to the durability and the strength and integrity of the building. And then we see this kind of news in the market that building collapses leading to so much of casualties. So I have taken two details or two sort of single slide studies. One is a 4-story, 60-year-old commercial building which collapsed in Sector 17, Chandigarh. So I have a short video also which was viral online. You can see so this building was not a planned demolition. It was a sudden collapse. Within a fraction of seconds, the entire building collapsed. And unfortunately, this building was about to be repaired or rehabilitated. Unfortunately, there was no one inside the building because the building was under renovation. Why it collapsed? There are a lot of causes behind that. Some are saying they are not providing the proper temporary support. Some are saying that the work is not going on in the correct way. Some are saying there was no assessment of the building prior to the rehabilitation work. But what we can understand from this collapse, factors such as the age of the structure. As you can see, this building is 60 years old. And what we see that buildings are majorly designed for 50 to 60 years of life, or maybe up to 70 years. Now, this building has almost crossed its life. We can see the building, visually, it is having no deterioration, no signs. But if you see inside the building, inside the structural elements, they might be having stresses. They might be suffering with some deteriorations which were being cosmetically repaired, which were not visually seen, but they are present. For example, if there is corrosion, if you are putting some patch material over the corrosion, it will not recover. It will not be getting stopped. So corrosion, once started, will continue unless it is properly treated, unless it is properly removed and treated, and some measures which can prevent the further corrosion, they are applied. So again, the given that the Chandigarh falls in seismic zone 4 buildings, especially older ones, they are typically expected to undergo the predicted structural audits, and this building was not undergone through that structural audit process. Lack of timely audits and maintenance, they accelerated deterioration, shortening the life of the building. The collapse of the aging structures, it resulted in significant embodied carbon loss, as all material and energy invested in the original construction was wasted. You can see, it might have taken more than 2 years or 3 years to construct the entire building, but it took only 10 seconds, hardly 10 seconds to get it demolished completely. The incident highlights the need for greater compliance with statutory safety protocols, timely audits, and technical oversight during any form of structural intervention. One more case from Surat, where 7 were killed and more than 15 were injured. There is a 18-story residential tower from 6th floor. to the first floor, it pancaked, it collapsed. So there are certain more cases which have happened. Like we can go in detail about those like cases, why it has happened, and how they can be prevented. We'll now directly come to the main topic of our presentation, which is the structural audit. So this structural audit, it is basically bridging, acting as a bridge between the safety and sustainability of the infrastructure. A structural audit we can define as a systematic technical examination of any existing structure to assess its current condition, identify deterioration or distress, estimate remaining service life, and recommend appropriate actions including repair, rehabilitation, retrofitting, or demolition. So the decision whether we have to repair the building, we have to rehabilitate the building, we have to retrofit the building, or ultimately we have to demolish the building, it has to be an informed decision. It should not be like that building has crossed certain years of life and we have to demolish it. Yeah, we are having tools available, we are having methods available through which we can assess the remaining life of the structure, through which we can assess the properties of the material in the building, through which we can assess the durability, serviceability, functionality of the building for the future use. So any decision regarding the repair, rehabilitation, retrofitting, it should be taken after a proper structural audit. I would like to spend some time in discussing about these 3-4 terms: repair, rehabilitation, retrofitting, or demolition. So when we say repair is basically the cosmetic treatment of the building which do not give any benefit or any advantage to the structural integrity or its performance. We can do the cosmetic treatment while the building is still in use. And rehabilitation means we are doing some treatment in the building which are meant to give the building its original functionality, its original strength, its original durability. If a building is constructed 20 years back and we are rehabilitating building, it means we are giving some treatment. It may be in terms of repair, it may be in terms of the strengthening that will bring back the building to its original condition. And retrofitting, when we say retrofitting, we are adding something to the existing building. Building constructed 20 years back, 30 years back may not be designed for the seismic aspects. So now if we are assessing the building in 2025, then we are having codes available for the seismic retrofitting also. We are having codes available for the seismic design. So we can now design the building, we can now analyze the building based on the seismic aspects also. And if found deficient, we can add some seismic arresting elements in the building in the form of the shear walls, in the form of bracings, in the form of dampers, or in any other form, making the building earthquake prone also, earthquake resistant also, sorry. Then demolition. If after analysis it is found that the cost of rehabilitation or retrofitting is becoming almost 70% of the cost of construction, then in that case we may decide to demolish the building instead of going for the retrofitting, because retrofitting may require very high level of supervision, and after demolition a building can be constructed very easily if the cost of construction is approximately so cost of retrofitting is approximately 70% or so of the cost of new construction. So structural audit, what is happening these days in the name of structural audit, people are going to the site and doing a visual inspection only. They are just visually checking the building. They are just looking at the building, clicking some photographs, making some inferences in terms of the cracks are found, the dampness is found, and so and so. Actually, this is not the part of the structural audit. This is one of the aspect of the structural audit, which is termed as a preliminary visit. In visual inspection, we have to look for the things in the building. If a building is being assessed after suppose earthquake, then the auditor, it must be having that much of knowledge that he can identify which elements may show which kind of distresses after the earthquake. If auditor is looking at a beam and a number of type of cracks are available, then the auditor must be able to clearly classify, define the different types of cracks. The crack is running throughout the beam parallel to the reinforcement. What does it mean? The crack is at the center portion of the beam. What does it mean? If it is at the near the support in the inclined direction, what does it mean? If there is any other sign of distress, the auditor must be having that much of knowledge that it can clearly understand what could be the probable reason cause for this distress. So this visual inspection is a scientific evaluation, which is a combination of the inspection, testing, and engineering judgment. So while doing visual inspection, we may have to go with some basic entity test also. So a structure that is unsafe, it cannot be sustainable. So if we are assessing a structure which is constructed 30 years back, and if it is found unsafe, then that structure will not be termed as sustainable structure. Conversely, a structure that is maintained well reduces material and energy demand and will become sustainable. So if we are having proper audits of the structures, timely audits of the structures, and we are maintaining the structure as per the findings of the audit, then we will be able to get the maximum efficiency, maximum utilization out of that building. Now, why audits are critical to the built environment? If we see, there are multiple reasons of going with a structural audit. So how it can benefit the built environment? The first one is the sustainability goals. So through audits, we are able to reduce the construction waste. If we are able to give some life to the building through proper assessment, through proper remedial measures, then we will be able to give some more life to the building, reducing the construction waste, which will be developed as a part of its demolition. Saving natural resources and energy, since we are preventing the demolition, so we will be saving the natural resources and energy which will be consumed during the new construction. Aligning with the green building principles. So this is also one of the target which we can achieve through this audit, that we can be aligning with the green building principles through these audits. For aging structures, we can evaluate the integrity and the remaining service life of the structures, and thereby, if it is found possible, then we can enhance the durability and extend the usable lifespan of the existing asset also. Truly speaking, approximately 90% of the structures that are underwent audits, we are able to give them additional life through the repair, rehabilitation, or retrofitting. So there is hardly 10% of the buildings which cannot be retrofitted, and which cannot be made which cannot be enhanced for its durability and lifespan. So we can easily enhance the durability and the life of the building if the buildings are properly audited and the remedial measures are planned based on the root cause of the deteriorations and defects in the building. Then safety of occupants. So if we are doing proper audits, if we are doing proper maintenance of the building based on the findings of audit, then we are giving a safe environment for the occupants of the building by preventing the sudden failures and collapse and avoiding injuries and fatalities. And in a way, we are also ensuring the compliance with safety regulations also. Already we are having some codes in action. We are having some guidelines at the state level, at national level, which mandates the audits of the building. Change in use or loading of the building. This is also one of the key aspect which necessitates the structural audits. So we have in many times some buildings which are earlier used for residential purpose. Now over a period of time, the use has changed. It is being now used as a store building, or it is now being used for the commercial purposes. So the loading criteria for the residential purpose is different from that of the store or the commercial purpose. The building, it has gone it has already gone through its half of the life, and now we are changing its use, and this becomes more critical. So whenever there is a change in the use or loading of the building, then we have to go for the structural audit, which will require the assessment of the structure's capacity to carry the increased or the altered load. We will identify the need for strengthening or retrofitting requirements based on the analysis. If the building is like earlier designed for some heavy loads and now we are converting the use of the building to some light loads, it may not require certain like modifications in terms of the strengthening or retrofitting. But if a building which was earlier designed for some small loads and are now being converted to carry some heavy loads, then such buildings may require further strengthening. Somebody like a building of suppose G+2 constructed 20 years back. Now they have decided to add 2 more floors in the building. So building foundation and the 2 floors, they might not be having that much of capacity that they can sustain 2 further loads, 2 loads of floors. So in this case, we have to strengthen the building foundation. We have to strengthen the G+2 arrangement first, and then only we can go for the vertical expansion of the building. But this is possible through proper structural audits and assessment. Next is the cost-effective maintenance. So if we are having timely audits, then we will be like spending very less on the maintenance activities, because we will be like arresting the defects and the deteriorations at the early stage. So this will lower overall maintenance cost and reduce the chances of emergency interventions, which are sometimes costlier, or not sometimes, many times it is always costlier. Regulatory compliances. So these audits are also meant to like fulfill the regulatory compliances, to comply with the legal requirements, avoid penalties or notices, and provide documentation for clearances and certifications. This is also one of the reason why we go with the structural audit of the built environment. Disaster assessment. So we can like take it as a forensic assessment also. So if there is a disaster, if there is an earthquake, and post that earthquake, if a building is distressed, showing sign of distress, then the audit is mandatory. We have to first go for the structural audit of the building to check the residual strength of the structure, whether structure can be further used in its current condition or not, or it needs some strengthening or retrofitting before any use. To assess the extent of damage and required repairs, rehabilitation, and retrofitting. The usability of the structure is also assessed through the proper structural audits. Then insurance and valuation. Now it is also like in India as of now, we are not linking directly to insurance and valuation, but abroad it is a practice that before getting like any building, insurance and valuation, we have to go through the proper structural audit, and based on the audit report findings, the insurance and valuation is to be decided. So this will be coming in India also, and like very early in next coming few years. So this audit will aid in property valuation for buying or selling purpose. So before buying any property or before selling any property, we have to go for a structural audit. For example, like in our case also, if you are going to like purchase any flat, not a new flat, a second-hand flat, then we have to go first through the structural audit. We should ask about this, whether this building has been audited earlier or not. If it is audited, you should see the audit findings. The audit findings will clearly speak what is the condition of the building that you are going to purchase, and your decision may be like depending upon the findings of the audits. It will help in obtaining insurance or loan approvals. It will provide a baseline for estimating damage after disasters also. So these are some of the purposes for which the audits are being used in the built environment. Now, like let us proceed with the audit methodology. How these audits take place. We have right now seen the audit about what is the structural audit, what is its role in the built environment, and why we are actually going for the structural audit. We have seen a lot of cases of the buildings and bridges which require a structural audit because of its age. Now, how we carry out the structural audit. So very first step in the structural audit is the document review and critical visual inspection. So what we do, like whenever we are going for an audit, we will be first asking the client, like whosoever is going for the audit, for the proper documents of the building. As-built drawings, we ask for the design documents, we ask for the layout plans, we ask for structural drawings, we ask for any repair or strengthening work earlier carried out, we ask for that. maintenance records, we ask for that. So all these sort of documents we have to ask from the client first. We have to ask from the owner first, and then we have to go for a thorough review of those documents. From those documents, our critical visual inspection will be directed. Like what we have to look into the building when we are going for the critical visual inspection. So this is a very crucial step. Generally, this step is ignored. What we generally do whenever there is a need for an audit of any building, we straight away go to the site and start doing the audit. However, the correct way should be, you should first investigate, you should ask for the documents of the building. Based on the documents, you should plan your inspection, what you are going to look into the building. You should look for something in the building, and that will be decided based on the review of the documents. So after the critical visual inspection, we have to decide the non-destructive testing. Again, what is prevailing in the market, whenever there is a need for a structural audit, the owner directly says, or someone suggests, why not test the building, go for the non-destructive testing, and you approach some testing labs, and they are having facilities of non-destructive testing. There are number of types of tests available. So they will come to your place, they will do all the type of testing and will give you a test report. And that test report will give you some idea what is the strength, what is the durability properties, what is the chemical properties of the material, but it will not give you any conclusion what to do next. So based on that, if you are asking the contractor to work upon, the contractor will have its own set guidelines. It will not be like going through the audit report or audit findings. It will be straight away applying the remedial measures what is already in practice. So the correct way of NDT is after critical visual inspection. So based on the critical visual inspection findings, we decide which elements we have to test, what test we have to conduct, how many tests we have to conduct. So it is very much important to select the correct elements for testing, to select the correct test for the testing, and to select the correct area for the testing. So that can be done only after proper critical visual inspection. So these inspection findings basically serves as a base for deciding the non-destructive testing plus the partially destructive testing and the laboratory testing. So if we are able to assess the properties of the material through non-destructive testing only, we directly go with some conclusions. If it is not possible to assess or to get the properties of the material directly through non-destructive testing, we have to go with the partially destructive testing. And in case, again, if we are not able to confirm the cause, then we may have to go for the laboratory testing also. So once we are having these data in place, the data of the document review, critical visual inspection, NDT, PDT, and laboratory testing, then we can do a condition assessment and the analysis of the building to find out the deficiencies. So this is the last step which we have to take in the audit methodology, starting from document review, NDT, PDT, laboratory testing, and then the condition assessment and analysis of the building. So this analysis will let us know the deficiency in the building. Analysis, I mean to say, is the structural analysis of the building. It may be done at a local level also or the global level also. So why these multiple steps are important? Why we need this systematic inspection methodology? First the document review, then visual inspection, then NDT, PDT, then lab testing, then analysis. Why not directly inspection and report? So this is a synergy of multiple tools. Why we are doing so? So by integrating data from multiple sources, a more holistic view of the structure's health may be developed, considering both the surface and the internal conditions. So by visual inspection, we will be able to just see what is at the surface. Through testing, we are able to quantify the extent of the deteriorations. And through laboratory testing, we are able to find out the properties of the material, the chemistry inside the material. So this integrated approach reduces uncertainties and leads to more accurate diagnosis of the problems, enabling better informed decisions about repair and rehabilitation. So this is very much important. If we want a accurate diagnosis of the problem, we should always go with the correct approach, which is this testing before inspection, then testing, and then analysis. So limited perspective of single method. So these are the reasons why we are going with the multiple tools. So unique insights from different tools. Visual inspection, it provides only the qualitative overview of the structure's surface condition. NET methods, they provide the quantitative data on the in situ properties of materials in the presence of defects. And this laboratory testing, it provides detailed information about the material composition, strength, and deterioration mechanism. So this integrated approach helps us in diagnosing the deteriorations and diagnosing the issues correctly, and thereby helping us in taking the informed decision about the repair, rehabilitation, and retrofitting of the structure. For example, visual inspection might reveal cracking, which can then be investigated further using NET to determine the extent and depth of the crack, and laboratory testing to understand the cause of the cracking. So one way is just we are having a crack and we will Google some crack repair methodology and we'll do the repair. The second approach is we are having a crack for which we are not certain what kind of crack is this, what is the cause of this crack, and we should go for the NDT test for the crack to find out the extent of the cracking. And if we are not able to find out the cause of cracking further, we can go for the laboratory testing to understand the cause of the cracking. So this entity might indicate a potential problem area, which can then be confirmed and characterized by core sampling and laboratory analysis. This is where the PDT and laboratory test come into picture. Now we're having standards also, and very soon we are about to get our first Indian standard for the building services, which will be focusing on the audit of the structures. So it will be in wide circulation next month, and probably we are able to have our first Indian code for the structural audits next year. So as per the standards, like a combination of ISO, IS, and IS30 guidelines, we're having 5 stages of the audit. The very first stage is the visual inspection by competent structural auditor. The second stage is the non-destructive testing and finalization of the audit report. Non-destructive testing is a general name. It is covering PDT as well as the laboratory testing also. Stage 3 is a strengthening or intervention design by structural engineer and vetting by the structural auditor. Stage 4 is the implementation of stage 3 by executing agency, and stage 5 is a post-implementation audit for the verification of the executed work. So this is the complete process of the audit. So if you are going through an audit, then you might be going through only stage 1, stage 2, stage 3, or stage 4, or stage 5. So the complete process will be through these 5 stages. So, or if you are having some stage 1 investigations and you're planning for some remedial measures, then post implementation of those remedial measures, the building needs to be again assessed whether the identified stresses are being resolved or not. The issues are being resolved or not. This is a stage by stage process. I have taken 2 stages only for the audit. This is the complete audit process. If we are asking about the stage 1, then we have to first identify the aim and objective of the audit and scope of work. So whenever we are going for a structural audit, whether we are the owner or the auditor, it is very important for both of us to understand the aim and objective of the audit and the scope of the work that has to be included. And once we have defined the aim, objective, and the audit scope, we have to appoint a structural auditor. A structural auditor then carry out the visual inspection of the structure. After visual inspection, a report will be prepared, and if the aim and objective of the structural audit is fulfilled, then the audit will close here itself. Stage 1 audit may close here. If there is no findings, there is no suspicion, there is no requirement for the quantitative analysis, then we may end the audit process at stage 1 itself. But if the aim and objective of the structural audit is not fulfilled, we have to move to the stage 2. So stage 2 will lead to the damage and deterioration assessment and material evaluation. So here we have to carry out the NDT and other tests to assess the condition of the existing material and the structure components by independent laboratory, or it may be done through a structural auditor as well. So the decision has to be taken collectively by the auditor and the owner both. So the NDT report, when you are getting some testing done, then the report should include the following: the objective of the NDT, the brief about the various tests performed, the methodology adopted, analysis of data to drive some conclusions and the recommendations based on the test. So this is a general guideline given in the code that you have to carry out the entity test, and post that you should get a report which must contain all these information. Then based on this, the auditor will prepare the test report and a review and the recommendation of the auditors will be coming into. Then estimation of the demands and capacities. This will be done through the analysis and identification of the deficiencies and inadequacies in the building. And then the preparation of the final report, which will be submitted to the client for review. And the report will be based on the visual inspection findings, the review of the design and drawings, NET and other test, and assessment and suggestion for the future course of action will also be given in this report. So report on demands on as built structure, report on existing component capacities, report on deficiencies and recommendations for further action. This will be the part of this report. So up to stage 2 is crucial. Like stage 1 and stage 2, they are crucial. From stage 3, we'll start the development of the remedial solutions, the retrofitting design, the rehabilitation design, the strengthening design. So that will be a broad thing we'll be taking up at some other point of time. So I'm from critical visual inspection is simply like we have to look for something in the structure. But for NDT, like we are having different methods, different tools available through which we can assess the building. So the very first is the cover meter test. We're having different types of instruments available in the market, which are capable of identifying the location of the rebar as well as the cover to the rebar. Whatever is a reinforcement cover available and wherever the rebar is located. So we are able to find out that through these instruments. So quality control to ensure correct location and cover to reinforcing bars after concrete placement, it can be done for the existing structures. Investigation of concrete members for which records are not available or need to be checked. We're having the deficiency of the drawings. Like in most of the cases, you're not able to get the structural drawings or even the layout plans of the building. So in those cases, these instruments can help us in preparing the layout plans, in preparing the as-built drawings. By identifying the location of the reinforcement, the spacing between the reinforcement, the cover to the reinforcement, and all these things. And further data can be further verified through other modes of testing. Location of the buried ferromagnetic object other than reinforcement, water pipes, steel joints, lightning conduits, etc. They can also be detected using these instruments. So we are having multiple options available in this instrument. It is not so that it will detect only the metals. There are modes which are available for the detection of the wood, detection of the plastic, detection of the other metals. So based on the required inputs, you can choose a mode of selection, mode of operation for these equipments. Then next is the rebound hammer test. So rebound hammer test basically is used to check for the surface hardness of the concrete surface. We can assess using this rebound hammer. We're having different kinds of rebound hammers available with us. So P type, N type. Earlier we're having original Smith rebound hammer, which was analog type. And nowadays we're having the fully digital rebound hammers, which can directly give you the value of compressive strength also. Although the compressive strength is not reliable using rebound hammer, unless you have carried out a correlation between the rebound values and the core compressive strength. So although it says it is used for assessing the likely compressive strength of the concrete with the help of suitable correlation between rebound index and the compressive strength developed in accordance with the clause 5.2 of IS 516. So there is a IS code available for this code, which is having guidelines through which you can correlate the compressive strength of the concrete with the help of the rebound index. Generally, what happens, there is a graph provided along with this rebound hammer. So what people do, they will directly perform the rebound hammer test, take out the average readings using 6 rebound indices or 9 indices, and based on the graph, they will predict or evaluate the compressive strength of the concrete, which is actually not the correct way. If you have to estimate the compressive strength of the concrete in the existing structure, and it should be done strictly in line with the clause 5.2 of IS 516 part 5 section 4, because the graph which was being developed, it is in the laboratory on the standard in the standard conditions on a standard cube under the standard conditions of testing. So the same graph cannot be directly applied to the site. So this IS code strictly says if you have to correlate, you have to do it through the correlation of the compressive strength and the rebound number conducted on the cubes cast from the same material which were like being placed at the site. Or if the cubes are not available, then you can like extract the cores from the same elements and can perform the rebound number test at the same location and can correlate the values of the rebound number and the compressive strength for at least 9 cubes for 9 samples. Based on those samples, you can create a graph of which will be specific to the site, and that graph can be further used to estimate the compressive strength of the concrete for the remaining of the portion. So like in simple way, if there is a huge structure in which the concreting was done in a single go from the same material, the same grade of concrete, the concrete is cast, then you can like extract 9 samples of cores from those elements and can perform the rebound number test, the same locations, along with the UPV test also. There is one like criteria again. If the UPV value is more than 3 km per second, then only we can consider that location for the correlation. If the value of UPV is less than 3 km per second, we may not consider that for the correlation. So based on that correlation curve, you can further like predict the value of the compressive strength for the remaining of the structural elements. This is the correct way how we have to assess the compressive strength. Second is the assessment of the uniformity of the concrete quality. So this is the like main purpose of this test. We want to assess the uniformity of the concrete quality in the same element among different elements, or we want to like compare the surface hardness of one structural element with respect to the other surface structural element. Assessing the quality of concrete in relation to the standard requirements, and assessing the quality of the one element of concrete in relation to the other. So these are the purposes of the rebound number test. Then comes the ultrasonic pulse velocity test. These are the different kinds of equipments available in the market for the ultrasonic pulse velocity test. The purpose of this test is basically to check the homogeneity of the concrete and the presence of cracks, voids, or honeycombing or hairline cracks inside the concrete. Like this will be like doing the assessment of the internal properties of the concrete, inside of the concrete, because we will not be able to see the concrete visually from inside. Will not be able, rebound number will not be able to give you any information of the concrete from inside. This UPV test will help you in giving that information. So the quality grading of concrete is based on the pulse velocities as per IS code. So there is a table which says the quality of concrete will be doubtful, good, or excellent based on the velocity criteria. Estimating the depth of the surface cracks. This is one more application of the UPV. Like if you are having cracks over the surface of the concrete, then we may like estimate the depth of those cracks without actually like drilling a core. But again, that estimated depth will be having some variation. It is having some limitations. So ultimately, if you want to go for the most accurate crack depth estimation, there is no better option other than core. To determine the dynamic Young's modulus of the elasticity, we can determine this also using the pulse velocity test. The next is the electrical resistivity test on concrete. So again, we're having different types of equipments available in market which can like assess the resistivity of the concrete. So this test is done as an alternate to the half cell potential test. So whenever we are not able to like drill the concrete, when we are not able to get the reinforcement, buried reinforcement inside the concrete, then we may perform this electrical resistivity test on the concrete to check whether the concrete is conductive or it is resistive to the flow of the current. So if the resistivity is high, it means that there is very less chance or lower probability of the reinforcement getting corroded. If the resistivity is low, then it indicates that the concrete is a bit porous and there is high chance of the reinforcement getting corroded. So this resistivity test will in some way give an indication of the likely corrosion activity happening inside the concrete. So concrete resistivity is a measure of the ability of the concrete to resist the flow of electrical current. So simply it is the electrical circuit is completed, the flow of current will be like tracked, and you will get the resistivity value from the concrete. In the context of corrosion, the lower the resistivity, the higher the likelihood that the steel reinforcement will corrode. High resistivity concrete tends to slow down the corrosion process because it impedes the movement of the ions necessary for electrochemical reactions that cause corrosion. Only gives an indication of the risk of corrosion, not the actual corrosion rate. Again, like this is an alternate to the half cell potential test or the I-core test, which are used for assessing the probability of corrosion and the rate of corrosion. So through this test, we can like have an indication whether we need to further assess the same area of the structure or not, or we can simply escape that area. Surface conditions, for example, we're having moisture, temperature, they can significantly influence results. So resistivity values are like they are influenced by the presence of the moisture and the temperature. So they are only effective for shallow depth corrosion assessment. So if you're having a deep concrete member, so we're having a member which is having like a depth of suppose 300 mm or 400 mm, and the reinforcement is present beyond that. So the electrical resistivity method may not be able to accurately assess the connectivity or the resistivity of the concrete up to that depth. So this method may not be that much successful if we are having very deep members or the reinforcement is buried deep inside the concrete. Then comes a half cell potential test. So these are the different methods, this different equipment available for the half cell potential test. So this is basically a half cell which is completing a complete cell when it is getting connected to the reinforcement and the concrete. So this half cell potential test, this will be giving us the probability of corrosion. Again, this test is not going to give us the rate of corrosion by with what rate the corrosion is happening. It will not give you. So what it will give you, it will give you the instantaneous rate of corrosion. Like at the time of testing, at the location of testing, there is how much probability of corrosion. So generally we use a half cell, which is a copper sulfate solution, and the cell will be completed through the concrete. We'll attach this correct clip to the reinforcement and we'll check for the potential. So if you're getting potential in the range of minus 200 or more negative, then this will indicate very less chances of corrosion happening at the time of testing. If it is between minus 200 to minus 350, there will be the corrosion activity, the probability will be uncertain. 50% chances the corrosion are happening and 50% might not be happening. So we are not able to correctly predict whether there is corrosion or not. And if the value is between minus 350 to 500, then there is a very high rate of corrosion, 90% probability that corrosion is happening at the time of testing. And if the value is going beyond minus 700, minus 600, minus 700, and this is a case of severe corrosion happening in the reinforcement. So this half cell potential measures cover the estimation of the electrical half cell potential. The results are affected by moisture content, concrete resistivity, temperature, concrete cover, chloride content, and carbonation. Gives qualitative, not quantitative information on corrosion. Means it will not give you the rate. It will not give you how much corrosion has happened. It will just give you give you the probability that corrosion is happening. Does not detect corrosion if steel is electrically isolated. So if the steel is electrically isolated, it will not be able to like detect the flow of ions. So it will not be able to like give you any meaningful results. Then comes the ultrasonic tomography. So ultrasonic tomography is basically the advanced version of the pulse velocity test. So in pulse velocity test, we are having two probes, which will be like giving us then information inside the concrete. And this ultrasonic tomography, we are having multiple array of probes. Like we're having 8 channel, 24 channel, 32 channel like array, which will be like inferring the quality, the property of the concrete from inside. So determination of the thickness of the concrete element, the concrete quality assessment, and the verification of the presence or absence of the structural defects such as voids, delamination, and honeycombing. So the purpose is again the same, but it will give you the information with more accuracy. So this is the equipment. Having in UPV, we are having only 2 probes. In this, we are having multiple channels. We are having 1 to 8 channels. Each is having 3 like probes, and this is how it will work. Like from a single probe, the pulse will be initiated and it will be received by the remaining of the probes. And similarly, the process will continue, and the rest of the other probes will be like transmitting the waves, and it will be received by the rest of the probes. And after the combination of all these, it will be getting the information about the quality of the concrete from inside. So it is a much more accurate and precise method of getting the information about the homogeneity of the concrete, about the integrity of the concrete, about the presence of the cracks, voids, or delaminations inside the concrete. And this also gives us the thickness of the concrete element. We get some back wall echo through this instrument, which will indicate the presence of the end of the equipment, and we can like, estimate the thickness of the instrument based on the back wall echoes. Then comes the carbonation test. So carbonation test is basically done to check for the depth of carbonation inside the concrete. So for this test is most applicable for the old structures. The structure is more than 15 years of age or more than 20 years of age, then and it is in a condition where there is presence of carbon dioxide in the atmosphere, and there are very high chances that the peripheral, the concrete in the peripheral elements, it is getting carbonated. So in such cases, it is like important to check for the depth of carbonation, because the carbonation is something which will ultimately lead to the corrosion. So we have 2 types of corrosion, primarily 2 types of corrosion. One is the carbonation induced and one is the chloride induced. So if the corrosion is carbonation induced, then we can detect that using this carbonation test, which can be connected on the extracted cores or on the freshly like broken concrete surfaces. Or like sometimes we can also do this by drilling inside the concrete and spraying the phenolphthalein indicator. So if the indicator is changing color from lilac to pink, then it indicates that the concrete is not carbonated. And if the color is not changed, then it indicates that the concrete is carbonated. Generally, the pH of 9 to 9.5 is a like benchmark. If the color is not changing, it means it indicates that the pH has reduced below 9.5 or 9. And if the pH is like reduced, it will ultimately initiate the corrosion by like breaking the active layer around the reinforcement, like reacting with the CaOH whole twice, converting it into the calcium carbonate. So there is a chemistry behind it. Now coming to the digital transformation in structural audits. So as of now, till now, we have seen there are tools available for assessment of the structures. So now we have now like changed with the advancement in the technology. We are having tools available which can further help us in like becoming more precise about the findings of the audit. So the first one is a BIM enabled audits. So what we do in this, like we are having a structure which is 30 years old or 40 years old, and we are not having structural drawings available with us. BIM model is something which will be like not possible. Then what we can do, we can like create models using the visual inspection findings, using the on-site measurements and the testing results. So we will be creating models using the same softwares like tools like Revit, Tekla, or Architect or AutoCAD. They can be used to create the models, and we can like import these models, and then we can like help the laser tools also. We can help the take help from the drones also, and that photogrammetry to capture the as-built geometry of the structures more accurately. And all these things can be like incorporated into the model. Then whatever model we have created, we will be like embedding the data into those like elements. For example, we are having some findings of the audits in the form of the crack locations, in the form of carbonation depth, in the form of the core test results, that is a compressive strength test, or we are having the pH, chloride, sulfate content values. or we are having UPV values or the corrosion map, then we can like geotag, we can like tag all these to the respective elements in the model. And each data point also carries its metadata in the form of the test data, result, technician, severity, temperature conditions. Everything will be there with that tag data. If you're having one beam which is having like signs of cracks and carbonation, and along with the crack and the carbonation, we'll be having some more information: what kind of crack it is, what is the depth of the crack, what is the length of the crack, what is the location of the crack. If there is like further, if the crack is ongoing, if it is live, then we may have the information about the activity of the crack also. Similarly, for the carbonation depth core test results also, we will have the metadata available along with the main data. Then based on this, like we can analyze and visualize the our structure. So we can create heat maps or color codes which can show the condition of the elements. We can have different color codes for the different zoning. So severe zones can be given red color, and the healthy zones can be given the green color, and so we can also create corrosion maps also in this. So like with the help of that, we can like take informed decision. We can visualize the deterioration patterns over time to predict future hotspots. And using the pattern analysis, we enable preventive and not the reactive maintenance. So we will be going for the like preventive maintenance rather than going for the reactive maintenance. So if we are able to bring this BIM model in the structural audit process, it will help us a lot in predicting the future of the building, what kind of defects may be generated, or what kind of iterations may be like developing in the due course of time, if the conditions which are prevailing, if they prevail for next few years. And accordingly, we can plan for the preventive measures. Life cycle integration. This will enable repair versus replace decision based on the objective data. The maintenance schedule is done directly within the BIM model. So we're having a maintenance plan directly in the BIM model itself, which will be giving information or like suggesting the when to maintain the building, when to start the building maintenance, and what kind of repairs or the activities to be taken up at what time of time. When this is combined with the costing data and carbon factors, so 5D and 6D BIM, we can quantify the economic and environmental impacts of every repair activity. So if we want to go beyond this assessment and the repair remediation to the economic and environmental impact, we can further feed the BIM model with these information of costing and carbon factors to get this. Then next is the drone based audits. So earlier, if we having some case where we have to audit a bridge over a river, if we have to audit 20-story building, if we have to edit a flyover with a very busy road inside, if we have to audit a bridge over a railway, then all such conditions, they are almost impossible to audit. So, but with the introduction of the drones and the implementation of the AI in the audit, so it is now possible to go for the structural audit for such kind of conditions, for such kind of structures also. So in the past, inspecting the upper stories of a facade, the soffit of a bridge, or the crown of an industrial chimney, it means scaffolding, rope access, or heavy staging, which are expensive, risky, and time-consuming, and most of the times impossible to conduct. Today, drones are redefining how we audit and inspect our structures. These drones are equipped with high-resolution RGB cameras, lidar scanners, or thermal scanners to capture aerial, high-quality images of the structures. So we can load the drone with any kind of instrument that we want. Whatever information we require from the building or the infrastructure, we can load the this drone with that kind of equipment. The data captured using drones is directly integrated with the digital platforms such as BIM. So whatever information we're getting from the drone, we can directly feed this data to the BIM model. Again, as in the previous step, we have seen how this BIM is revolutionizing the structural audits. There's one more thing, like when we are going with a drone-based audits, then the time of audit is also reducing significantly. For the audit of a multi-story building, suppose a G+20 building, it usually takes around a month or two with proper scaffolding and the safety arrangements. But if you're having drones in place, equipped with all the high quality RGB cameras, lidar scanners, and the thermal scanners, then we can do the audit of the same building in merely few hours. So it takes only hours to scan, to audit, or to visually inspect the entire building facade, which earlier could have taken a month or two. So this drone-based audits, it has significantly reduced the time of audit. And when we have reduced the time of audit, at the same time, we have also increased the efficiency. We have also increased the level of precision of the audits, because we're having the photographs, the images, the information as close as possible to the structure. Then comes the sensors and AI in audits. So we are having a lot of types of sensors which are used for the structural health monitoring these days, and the artificial intelligence is also coming into this to predict the deteriorations, that predict the defects, predict the level of damage in the buildings and the structures. So there are a number of applications. We can have different kinds of sensors which can give you the strain values, which can give you the crack information about the crack, which can give you the information about the settlement, which can give the information about the rate of corrosion, the depth of corrosion, the carbonation. Even the strength values can also be predicted using those sensors. So the IoT-based structural health monitoring system use embedded or surface-mounted sensors to continuously collect real-time performance data of a structure. So for the structures like dams, bridges, these instruments, they play a vital role. They are a mandatory part of the structure. So if you're having some dam constructed, then it is mandatory to install sensors in the dam. If you're having bridges, then it is now mandatory to install sensors in the bridges to monitor the deflections, to monitor the rate of corrosion, to monitor the appearance of the cracks, to monitor the strain levels in these structures. So strain gauges, accelerometers, corrosion probes, crack sensors, temperature and humidity sensors, all these are the different kinds of sensors which can be used, which can be installed inside the concrete to get the real-time information from those structures. And based on these real-time information, we can go for the real-time preventive measures also, which will help us in putting the structure in a danger zone. So artificial intelligence and machine learning enable automated recognition, prediction, and decision support from large volumes of audit data, such as photographs. Now, when we are having a lot of data and we are putting the data at a single place, suppose in BIM model we are feeding all the information, or we are training our data. We are training our different softwares. So then really having a lot of data, and based on that data, the AI it can itself predict what kind of deterioration is this. Although it is not 100%, right? If we are getting information only through AI, it will be accurate. A human intervention is again required just to validate and verify the data. So these are the digital transformation in structural audits. So drone-based audits, it can be used for the construction purposes for the buildings. In energy sector, we can use it for power lines, wind turbines, photovoltaic plants, pipelines. And in transportation sector, we can use this for bridges, pavement, railway, sky rail, embankment, tunnel. There's hardly any sector where this UV inspection is not applied. So this is all about the structural audits, the digital transformation in audits, and the net zero. So I'm open to any discussion.
Hello, sir. Dr. Nakul Gupta this side.
Yes, sir.
I was having one question. Do we have any other method apart from this for measuring carbonation? Because as we have studied that around at the pH level 10.5 to 11, our this corrosion starts. So, but naphthalene solution usually detect this thing after the pH goes below 9.
Mm-hmm.
So, apart from some new technologies like rainbow indicator, do we have, as we know that rainbow indicator is comparatively costly. So, do we have any other method?
Like we can go with the accelerated carbonation test, but again, as of now, like we're having for carbonation this naphthalene indicator and this rainbow indicators only.
Okay. So, I think so, sir. We have few questions in our chat box also. Like,
Okay. Okay.
we started, someone said that is rebound hammer test really reliable? Because
Uh,
according to him, it is based on surface hardness of concrete. Relating hardness to compressive strength seems to be bit out of way. Your views, sir?
uh, can I see the question, please? Okay, rebound hammer is based on surface hardness of concrete. Relating hardness to compressive strength seems to be bit out of way. Yes, absolutely. Uh, it is completely based on the surface hardness, and when we do testing using a rebound hammer, we actually get the hardness of the cover concrete only. And when we are going to estimate the strength of the concrete, it is a core concrete whose strength is actually required. So in case if we are planning to use this rebound hammer test to predict the compressive strength, we have to make some correlation with the site data. We have to take out the cores and test the value of the compressive strength on those cores and relate it to the rebound hammer. Again, if we are having carbonated concrete, then the data may be a bit surprising. You are having high values of rebound numbers, but the strength might be coming low. So that might be because of the carbonation at the cover concrete. So yes, like in my opinion, also we rarely rely on the rebound number data. We only use the rebound number test to assess the uniformity of the surface hardness. We rarely use rebound number test to estimate the compressive strength. And in IS code also itself says that if you're estimating the compressive strength using rebound number, the variation could be plus minus 25%. So if you're having a concrete of grade M30, so like M30 will be having a variation of plus minus 25%, 22.5 to 37.5. So there is no meaning of such data. So it should not be used for the estimation of the compressive strength directly. Okay, next question is, in my perspective, only for comparative study. Yes, absolutely, Dr. Binay Patnaik ji. Absolutely, I am of the same opinion. The rebound hammer should be used only for the comparative study. It should not be used for the rebound hammer.
And
Okay.
sir, Dr. Binay Patnaik has one more question downside that absolutely with the invention of new concretes,
Mm-hmm.
it's just reduced to surface hardness and comparative analysis, as the graphs have not developed for all new concretes to compare compressive strength.
Absolutely. The graph that we get with the rebound number, it is basically we are also not sure how the graph is being developed, because the manufacturer is not giving the information about the grade of concrete on which the test is being conducted. The manufacturer is not giving the environmental conditions. It is not giving the curing conditions. It is not giving any other information about that graph, how it is being developed. We are simply getting a graph indicating the rebound number values and the values of the compressive strength against the inclined horizontal, vertically upward and vertically downward case of the hammering.
Yes, sir. Thank you, sir.
And people are asking for the PPTs. Okay, at the end of the this FDP, we will collect all these PPTs and put it in a Google Drive. So from there, you all can download these PPTs. And to P. Joyson Silva, he is asking for 10 to 15 days duration training. For this, sir, you can contact
Uh,
someone who is the admin and we will connect you to Dr. Ankur Gupta.
Okay.
You can contact anyone from the admin in the WhatsApp
Yes.
group. So, and now we have, sir, has drone-based auditing started in India?
Yes, absolutely. Like we have started drone-based auditing in India, and like multiple projects have been completed in Delhi NCR itself. And like drones are basically now transforming the audits of the tunnels also. But when we are having tunnels, so in case of tunnels, it is very difficult to go inside and like inspect the segments, whether it is an ATM based tunnel or it is a segmental tunnel. So it is very difficult to assess the tunnels. So these drones are like something which is serving as a boon for the auditing. So drone based like audit has already been started in India, and it is in practice also. If you need like some more information, you can like connect further.
Okay. So, Mr. Jobil Varghese has asked, sir, what about crack width measurement?
Uh, Crack width is like surface crack width can be easily measured using the like different kinds of crack gauges available. Like crack rulers are available. You can use those to measure the crack width. I think like the question must be of crack depth. The crack depth is something which we can identify using the ultrasonic pulse velocity test. We're having like two methods available. One is the British method and one is the IS code method. Using those methods, we can estimate the crack depth. Again, the crack depth estimation is only an estimation. Don't rely on the results, because you may have some different actual crack depth values. Again, the values of the crack depth estimation, this crack depth will depend upon number of factors. So suppose if you are like performing the crack depth measurement, and between the probes there is some hairline crack which is not visible on surface, then your crack depth may be different. If there is some like honeycombing or voids inside the concrete, then also the crack depth will vary. If there is presence of moisture, then also the crack depth will vary. So there are a number of factors on which the crack depth variation will take place. But in any case, if we are not able to extract cores, then this is the only method available with us. We have advanced equipments also like in place using which we can estimate the crack depth. This ultrasonic tomography is also like capable of measuring the crack depth.
Sir, someone has asked that, sir, can we perform structural health monitoring using IoT and how?
Yes, we can perform structural health monitoring using IoT, but for that you must have a lot of data available with you. With whatever platform you're using, that must be trained first. Suppose like you are like trying to assess the cracks in a building, and that your system must have information about the like all the different types of cracks and their manifestation. Because directly like you cannot say if there is a crack in a building and you can like go for the remedial measure of like filling the crack with some epoxy or with some grout. The crack might be having some cause, so first that cause has to be identified and treated, then only like you can go for go for the remedial measure. So you can go with the IoT in case if you're having a lot of data available with you beforehand.
Uh, One question is there that during drone auditing to the building,
Hmm.
what are the important parameters to be considered?
Okay, very good question. Like during the drone audit of the building, the very first thing that you should like keep in mind is the permissions. So like a flying UAV is not like possible everywhere. So there are some regulations, there are some statutory guidelines. We have to take permission from the local bodies, from the state bodies also, from the municipal bodies also, from your nearby police stations also. So you have to get everyone informed about that. So this is the first thing that you should keep in mind. If you're planning for the drone-based audit, do take all the necessary permissions. Otherwise, you will end up with nothing, like with some like administrative thing coming in between. And as far as the parameters are concerned, like you should first define the objective. What is the purpose of your audit? If suppose the purpose is only to like have a visual inspection of the entire building, then you may just need the high resolution camera, RGB camera. in case if you want to look to assess the dampness, if you want to assess the seepage, if you want to assess the leakages in the building, if the issues are related to that, then you should have a thermal scanner like installed in the drone. If you want to like have the like corrosion mapped, then the corrosion analyzer must be there in the drone. So drone is basically a carrier. It will carry that equipment for which like you are going for a like test. So if you want simply the visual inspection, go with the RGB camera. If you want the corrosion mapping, go with the corrosion analyzer. If you want to go for the seepage analysis or the dampness analysis, go with the thermal scanner also. So these things you should keep in mind. What is the purpose, the aim of the your investigation, your audit?
Okay. So is there anyone else who want to ask anything? Akansha, you should take over
Yes,
from here
sir.
now.
Actually, like I wasn't able to deliver what I was planning. I rarely like go for the online sessions because these things, the audit kind of things, they are more like better delivered in like physical mode. So I hope like I have done some justice with the session.
Thank you so much, sir. You have answered almost all the doubts of the audience, and the delivery was quite effective. And you ensured that the role of structural audits in sustainable infrastructure is continuously covered. And your expertise in structural health assessment and rehabilitation has powerfully illustrated that net zero is not just achieved at the design stage, but we must ensure continuous validity throughout the structure lifespan. We really appreciate your efforts, which are invaluable for our faculty as well as all the audiences as well as future engineers. So thank you
Thank
a
you so
lot,
much.
sir.
Thank you. Like I'm available to take any further questions in case like if you have something in your mind that it is not clicking right now, you can drop me message. You can like send me mail, or you can like come through NICMAR also. You can like share your feedback on this. Like we'll be answering your question within 24 hours.
Yes, sir, and might be possible on 14th we will have your one more session on something advanced stage of this structural audit.
Okay,
So
great.
there also, yes. So we will come back to these things in that session also.
Sure,
So
for
I
sure.
think so we have answered all the questions. So we can wind up with this session, Akansha.
Yes, sir, yes. I would like to request all the participants to please switch on their cameras for the group photo. Thank you so much. So we now come to the formal closure of day 1 of the AICT sponsored FDP on digital construction and green design pathways to net zero. On behalf of Institution Innovation Cell, NICMAR Delhi-NCR, I would like to offer a heartfelt vote of thanks to all the delivers, to all who made this successful launch possible, to our leadership, thanks to our patron sir Tapash Kumar Ganguly, our coordinator Rajesh Goyal sir, as well as our co-coordinator, Dr. Nakul Gupta sir. To our speakers, a profound thanks to Dr. Murali Jagannathan as well as to Dr. Ankur Gupta for highlighting the necessity of structural audits. You have provided a magnificent start to this FDP, as well as to hold the organizing and working committee, as well as to all the participants. Thank you to our targeted participants, the faculty members, PhD scholars, for your commitment and active engagement throughout this evening. So before you log off, please ensure that you have completed the attendance form for both the sessions. This is essential for qualifying the ATAL certificate. We eagerly anticipate seeing you back online tomorrow, Tuesday, 11th of November for day 2, where we'll continue exploring the convergence of digital construction and green design. Thank you once again. Good night, and we wish you a reflective rest. The meeting stands concluded now. Thank you.
Thank you. Thank you so much. Thank you so much. Bye-bye.
Bye, sir.